Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a tool for you to practice for your entrance exams. There you will find a number of entrance exam question papers along with their detailed solutions and PDF. You can also download our app. The link is available in the description box. Students, let's move towards today's paper. We'll be solving TSMCET 5 August 2021 shift 1 paper. Different sections are there for the paper. You have about 80 mathematical questions in this paper as well. And this is what we'll be learning in this video. We'll be doing the 80 mathematics question over here. So let's start with that. Okay. So here's question number 1. It says A and B are the subsets of the real numbers. Every element x of A is mapped to an element of B by this given rule, that y of x is given by this expression if x is not equal to 1, and it's given by -1 if x is equal to 1. Then what is the value of A? All right. Okay. So you're given y is 5x upon x minus 3 upon x plus 3. If x is not equal to -1, and it is -1 if x is equal to -1, right? Now, A is a set of domain over here. Is a set of domain. So, x minus 3 into x plus 3 cannot be equal to 0, which means x cannot be equal to 3 or -3. That means x can have any value of the real numbers except 3 and -3. Okay, simple as that. So we have option B as the answer. Hope you got this. Next is question number 2. The domain and range of yx is equal to cos x minus 3 are respectively. You have to find the domain and range of both of them. Here the domain is given by the function this, and domain of cos x is r. If I subtract 3 from it, there will be no change in the domain. No change in the domain. So domain of yx is all the real numbers, right? Also, the value of cos x always lies between -1 and 1. If I subtract a 3 from it, what will you have? -4 less than equal to cos x minus 3 less than -2, which simply means that the range will belong to -4, -2. So that means the domain is all the real numbers and the range is -4, -2. Option B is the answer. Hope you understood this. Then let's move to the next question, number 43. If f of 1 is equal to 0 and fn plus 1 minus fn is equal to 5n for all n belonging to the natural numbers, then fn is equal to. You are given in the question that f of 1 is equal to 0, and one more thing, that f of n plus 1 minus f of n is equal to 5n. If I say f of ampering n is equal to 1, so f of 2 minus f of 1 will be equal to 5, right? F of 1 is 0, which gives you f of 2 is equal to 5. Similarly, f3 minus f2 is equal to 10. f2 was already 5, so this gives you f3 is equal to 15. Now f4 minus f3 is equal to, I'm putting here n is equal to 2, here is n is equal to 3, so this is equal to 15, which gives you f4 is equal to 15 plus 15, that is equal to 30. Similarly, it will go on. Let's say for f5 also now. So here this is equal to n is equal to 4, so that's equal to 20, which gives you f of 5 is equal to 50. Okay, so that means for n is equal to n, we have f n minus 1 minus f n is equal to 5n. Okay, right. So next, the sum of the terms, that's t1 plus t2 plus t3 till tn. Also, I can write it like this. t1 plus t2 plus t3 so on till tn minus 1 plus tn. So let's subtract both of them. This is number 1, 2, subtracting both of them, you'll get a 0 is equal to, I'll keep this t1. So I'll write down t1. Now t2 minus t1 plus t3 minus t2 so on till tn minus tn minus 1 minus tn. Okay, so now t1 was the first term, that is equal to 0. Over here, you were given f of 1 is equal to 0, right? So that is 0. T2 was 5, so 5 minus 0. T3 was 15. 15 minus 5, right? And then it was 30 minus 15 till so on, like 5n minus 1. So that's equal to 0. I'll take this is 5, 10, 15, and 5. N minus 1. Here comes 5 common. 1 plus 2 plus 3 till n minus 1. You know the sum of n natural numbers is given by n into n plus 1 upon 2. So here n is actually n minus 1. So this will be equal to 0 plus 5 into n is n minus 1 and n minus 1 plus 1 upon 2, which makes it n into n minus 1 upon 2, 5n into n minus 1 upon 2. So we have option 5 into, okay, this has actually multiplied. This can be written as 5 n square minus n upon 2. That is option B. Hope you understood this. Let's move to the next question then. Question number 3, if f of 1 is equal to 0 and f of n plus 1 minus fn is equal to 5n for all n belonging to the natural numbers, then you have to find out the value of fn. We are given f of 1 is equal to 0. If I take n is equal to 1, this becomes f2 minus f1 is equal to 5, which gives you f2 minus 0 is equal to 5, or f2 is equal to 5 plus 0, or that is equal to 0. Similarly, if I take n is equal to 2 and n is equal to 3, this will be f of 3 minus f of 2 is equal to 10, which gives you f3 is equal to 10 plus 5, which is 15, and f of 4 minus f of 3 is equal to 15, yeah, which gives you f of 4 is equal to 15 plus 15, that is 30. Similarly, n is equal to 4, you will have f5 minus f4 is equal to 20, which gives you f5 as 50. So we will go till n is equal to n, which makes fn plus 1 minus fn is equal to 5n. Okay, now let's add all of them. You can say Fn is equal to, let's add f of 1 plus 2, 3, 4 till f of n. So this can be written as the first term plus second, third, fourth till the nth term. So this is equal to t1 plus t2, t3 plus t4, tn minus 1, tn. I'll subtract the two now. So after subtracting both of them, you will say 0 is equal to, I'll write a t1. I'll keep this t1, and next I can write t2 minus t1 plus t3 minus t2 plus t4 minus t3 till tn minus tn minus tn minus tn minus 1 minus tn. Okay, so that gives you tn is equal to t1. The first term was equal to 5 minus, sorry, it was f of 1, which is 0, plus t2 was 5. So 5 minus 0 plus t3 was 15 minus 5 plus 30 minus 15, and so on till tn minus tn minus 1. This gives you 5 plus 10 plus 15 till tn minus 1. So this will be, this tn minus 1 can be written as see, this can be written as 5 into n minus 1. Okay, I'll take 5 common from here. 1 plus 2 plus 3 till n minus 1. So see, this is the sum of n minus 1 terms. Sum of n terms is given by n into n plus 1 upon 2. So this is equal to 5 into n plus 1 upon 2, which gives you 5n into n minus 1 upon 2. That gives you 5n square minus n upon 2. So that is option D. This is the correct answer to the question. Hope you understood this. Let's move to the next question, number 4. If A is given by this matrix, then adjoint of A is equal to, you know this formula, note down this formula. Adjoint of A is given by determinant and A raised to power n minus 2 into A, where A is given by the matrix 1, 0, 0, 0, 2, 0, 0, 0, 3. Let's find out the determinant. 1 into 6 minus 0. Okay, these are 0, so plus 0, plus 0. This will give you 6. Easy one. So adjoint of A is equal to 6 raised to power n is equal to 3 in this case. This is a 3 by 3 matrix. So 3 minus 2 into A. That is 6A. Option C. Hope you understood this. Let's move to the next question, number 5. A is this matrix. You have to find out A raised to power 5. So you're given this is a matrix. First of all, let's find out A square. A square will be given by 1 minus 1, 1, 2 minus 1, 0, 1, 0, 0. Multiplied by 1 minus 1, 1, 2 minus 1, 0, 1, 0, 0. Let's multiply. So first row, first column. First row, first column. This will be 1 minus 2 plus 1 minus 1 plus 1, 0, 1, 0, 0. Then 2, 1 into 2 into minus 1 plus 0. Then minus 2 minus minus plus 1 plus 0. Then is 2, 0 plus 0 plus 0. Okay, the last one, 1 in plus 0 plus 0. Then is minus 1 plus 0 plus 0. then is 1 plus 0 plus 0. So let's add them. You will get, this will cancel, it will be 0, 0, 1, 0, minus 1, 2, 1, minus 1, 1. That was a square. Now a raised to power 4 can be 0 minus 1, 2, 1 minus 1, 1. 0, 0, 1, 0 minus 1, 2, 1 minus 1, 1. Let's multiply again. So first row, first column, 0 plus 0 plus 1. Then 0 plus 0 plus minus 1. Then 0 plus 0 plus 1. 0, first do this, and 0 plus 2. Then is 0 minus minus plus 1 minus 2. Then is 0 minus 2 plus 2. Then is 0 plus 0 plus 1. Here 0 minus minus plus 1 minus 1. Then 1 minus 2 plus 1. This gives you 1 minus 1, 1, 2 minus 1, 0, 1, 0, and 0. This is a raised to power 4. And a raised to power 5 is a. A matrix was 1 minus 1, 1, 2 minus 1, 0, 1, 0, 0. 1 minus 1, 1, 2 minus 1, 0, 1, 0, 0. So let's multiply again. You will have 1 minus 2 plus 1, minus 1 plus 1 plus 0, 1 plus 0 plus 0, then 2 minus 2 plus 0, minus 2 plus 1 plus 0, 2 plus 0 plus 0, then 1 plus 0 plus 0, minus 1 plus 0 plus 0, 1 plus 0 plus 0, which gives you, that is equal to 0, 0, 1. There is 0, minus 1, 2, and 1 minus 1, 1. See, this is matrix A raised to power 5. Let's write it here. 0, 0, 1, 0, minus 1, 2, 1, minus 1, and 1. What was A matrix? A matrix was 1 minus 1, 1, 2 minus 1, 0. Question number 5, if A is given by this matrix, you have to find out A raised to power 5. So A is this matrix. If I have to find out A squared, this will be given by 1 minus 1, 1, 2 minus 1, 0, 1, 0, 0, multiply 1 minus 1, 1, 2 minus 1, 0, 1, 0, 0. Okay, let's do the multiplication. First row, first column, first row, second column, and first row, third column. This will give you 1 minus 2 plus 1, minus 1 plus 1 plus 0, 1 plus 0 plus 0, 2 minus 2 plus 0, then minus 2 plus 1 plus 0, 2 plus 0 plus 0. Then you have 1 plus 0 plus 0, then minus 1 plus 0 plus 0, then 1 plus 0 plus 0, which gives you the matrix as 0, 0, 1, then 0, minus 1, 2, 1, minus 1, and 1. This is the A squared matrix. Let's find out A cube, which can be written as A dot A square. So this is 1 minus 1, 1, 2 minus 1 0 1 0 0 multiplied by 0 0 1 0 minus 1 2 and 1 minus 1 1. Let's multiply them. You will get 0 plus 0 plus 1 0 plus 1 minus 1 1 minus 2 plus 2 and 0 over here plus 0 plus 0. Then you have 0 plus 1 plus 0 and here you have 2 minus 2 plus 0 0 0 0 0 0 0 and 1 plus 0 plus 0, which will give you the matrix as 1 0 0. Wait, this is first row, third column. Okay, this is supposed to be 1. Okay, 0 1 0 0 0 1. This is the matrix. That means A cube is the identity matrix. This is identity matrix. And A raised to power 5 can be written as A square into A cube, which is A square into the identity matrix. So this is A square. This can be written as A into A transpose or A cube into A transpose, right? Sorry, A inverse. Okay, so that means A cube was this into this, which means A raised to power 5 is equal to A matrix inverse, which is option D. So this is the correct answer. Hope you got that. Let's move to the next question. Question number 6. Let A and B be 2 3 by 3 non-singular matrices. Then determinant of A, let's write down determinant A transpose into B, A is 27. Also determinant A B inverse is equal to 8. You have to find out this. Okay, you are given that A and B are two non-singular matrices. That means determinant of A is not equal to 0, right? Also, you are given that determinant A transpose BA is equal to 27 and determinant AB inverse is equal to 8, which gives you A transpose determinant into B, determinant into A, determinant is 27, which gives you A into B into A is 27, because the determinant of a matrix and its transpose are same. Next, over here, so I can write this one down as determinant of A square into determinant of B is equal to 27. Let's move here. A determinant into B inverse determinant is equal to 8, which gives you A determinant upon this is equal to 8. That means A determinant is 8 times determinant of B. Now I'll fill this value over here. So 8 into B determinant whole square into B determinant is equal to 27, which gives you 64. B determinant cube is equal to wait, I have done something. Okay, I'll choose a better one, like easy thing. Determinant of A upon 8 is equal to B. Now, determinant of A square into B is equal to 27, which gives you determinant of A square into determinant of A upon 8 is equal to 27. That gives you A determinant cube is equal to 27 into 8, or A determinant is equal to 3 into 2. That is equal to 6, right? Similarly, let's find out B determinant. That was equal to this, which is 3 by 4. Okay, you have to find out determinant of B transpose into A inverse into B, which is given by B determinant into 1 upon A, determinant of 1 upon A determinant, and B into B. Okay, so that is given by B's determinant is 3 by 4 and 1 upon A is 1 upon 6. B's determinant was equal to 3 by 4 again. So like this. This will cancel and you have 3 upon 32 as the answer. So you have option A as the answer to the question. Hope you understood. Next is question number 7. If Z1 is equal to this and Z2 is equal to this and Z3 is equal to this, then you have to find out the expression, this expression. Let's see. 1, 2, and 3. These are the three complex numbers which are given to you. So determinant of 1 upon Z1 plus 2 upon Z2 whole multiplied by Z3 upon Z2 is, let's solve this. First of all, I'll go for 1 upon Z1, which is given by 1 upon 1 minus 2 iota. Let's rationalize. So this will be multiplied and divided by 1 plus 2 iota, which will give me 1 plus 2 iota 1 square minus 2 iota square, which is 1 plus 2 iota. That is equal to iota square is equal to minus 1. So this will be plus 4. That will give me 1 plus 2 iota upon 5. Similarly, 1 upon Z2 will be given by, this is equal to 1 upon 1 plus iota. Let's rationalize this one as well. So you will have 1 minus iota upon 1 square minus iota square, that is equal to 1 minus iota upon 1 plus 1, which is 2. Now let's go to find Z3 upon Z2. What is that? 3 plus 4 iota multiplied by Z2 was equal to 1 plus iota. And we just rationalize that one to get this. So 1 minus 1 upon Z2 is given by 1 minus iota upon 2. So let's solve it. You will have 3 minus 3 iota plus 4 iota minus 4 iota square, which will be equal to plus 4 whole divided by 2. So that is 7 plus iota upon 2. This is the value of Z3 upon Z2. Now you have to find out 1 upon Z1 plus 2 upon Z2 whole multiplied by Z3 upon Z2. So this will be given by 1 upon Z1 was 1 plus 2 iota upon 5 plus 1 minus iota whole divided by 7 plus iota upon 2 mod. That's equal to 1 plus 2 iota minus 5 iota upon 5 multiplies 7 plus iota upon 2, which is minus 4 minus 3 iota 7 plus iota upon 10. That will give you minus 28 minus 4 iota minus 21 iota minus 3 iota square, which will be plus 3 upon 10. Right? Okay, so this is gonna give you minus 25 minus 60. Okay, this is 25, sorry. 25 iota upon 10. That is dividing numerator and denominator by 5. So this is minus 5 iota upon 2. Now you have to find the modulus of it or the magnitude of this one. I'll say this is given by, I'll take 1 by 2 outside, and this is root of, even 5 will be taken outside, right? So I'll take 5 by 2 outside, and no, 5 can't be taken outside. Wait. This can be written as 1 by 2 into root of minus 5 square plus minus 5 square. That is 1 by 2 into root of 50. So this is given by 5 by root 2. Question number 7. If Z1, Z2, and Z3, these are the three complex numbers, Then you have to find out the value of this given expression. Let's find out each and every term of the expression once. 1 upon Z1, 2 upon Z2, and Z3 upon Z2. 1 upon Z1 is given by 1 upon 1 minus 2 iota. Let's rationalize this. 1 plus 2 iota upon 1 plus 2 iota, which will be given by 1 plus 2 iota upon 1 square minus 2 iota square, which will be plus 2 square, that is plus 4. This is equal to 1 plus 2 iota upon 5. Let's find out 1 upon Z2 now. So this is 1 upon 1 plus iota into 1 minus iota into 1 minus iota. This is 1 minus iota upon 1 square plus 1, that is equal to 2. So this is 1 minus iota upon 2. Next, you have to find out Z3 upon Z2. So Z3 is given by 3 plus 4 iota, and Z2 we just solved, it was 1 minus iota upon 2, which will give you 3 minus 3 iota plus 4 iota minus minus plus. So this will give you 4 upon 2. That's going to give you 7 plus iota upon 2. Okay, now let's fill in all the values which we calculated in the given expression. So magnitude of 1 upon Z1 plus 2 upon Z2 multiplied by Z3 upon Z2. This is equal to 1 upon Z1 is 1 plus 2 iota upon 5 plus you have 2 upon this. So 2 upon Z2 will give you only 1 plus iota. 1 minus iota because the 2's will cancel. Okay. Multiplied by Z3 upon Z2, which is 7 iota, 7 plus iota upon 2. Now, this is gonna give you 1 plus 2 iota plus 5 minus 5 iota upon 5 multiply 7 plus iota upon 2, which is equal to 6 minus 3 iota upon 5, 7 plus iota upon 2. This is 42 magnitude of 42 plus 6 iota minus 21 iota minus 3 iota upon 10. Okay. So this is 3 iota squared. Sorry, this is going to give you plus 3. So this is 45 minus 15 iota upon 10, which will divide the numerator and the denominator by 5. You will have a 9 minus 3 iota upon 2. I'll take 3 common now. So this is 3 into 3 minus iota upon 2. That is, so let's find the magnitude. 3 by 2 will be taken outside. Root of 3 square plus minus 1 square. 3 by 2 into root of 10. Right. So 3 by 2 into root of 10, it's not in the options, but we have 45 by 2 over here. See, this can be written as 10 into 9 by 4, which is 45 by 2 root. That is option C. Hope you got that. Let's move to next question number 8. Again, a complex number. If 2 plus 2 root 3 iota is equal to k cos theta plus I iota sin theta when k is greater than 0, then you have to find out this value, the value of this expression. So let's compare this. I'll take up 2 plus 2 root 3 iota is equal to k into cos theta plus iota sin theta. Here you have see, if I'm comparing them, I'll first of all take here 4 common. This can be written as 1 by 2 plus root 3 by 2 iota. See, actually, I was trying to bring them in 1 by 2 and root 3 by 2 form so that we can have the angles over here. That's equal to k into cos theta plus iota sin theta. So here k's value is 4 and cos theta is equal to 1 by 2, sin theta is equal to root 3 by 2, which is the only possible value when theta is pi by 3. So cos pi by 3, you know this is equal to 1 by 3. Similarly, sin pi by 3 is equal to root 3 by 2, which gives you the value of theta to be pi by 3. Now let's fill in over here. You have to find out the value of 1 by root 3 cos 6 theta plus iota sine 6 theta, which is 1 by root 3 cos 6 into pi by 3, that gives you 2 pi plus iota sine 2 pi, right? That is equal to, see, cos 2 pi is equal to 1 and that is equal to iota into 0. So the answer to the question is 1 by root 3. So you have option B as the correct answer. Hope you understood this. Let's move to the next question. Question number 9, if x is equal to this complex number, y is this, then you have to find out 1 x square plus 1 upon x square into y square minus 1 upon y square. You are given, I'll start with x. You are given x is equal to 4 by 5 plus 3 by 5 iota, and y is equal to root 3 by root 8 minus root 5 by root 8. So here x square plus 1 upon x square into y square minus 1 upon y square is equal to, this can be received, x square plus 1 upon x square can be written as x plus 1 upon x whole square minus 2 y minus 1 upon y whole square. I will not touch it as such. Okay. Now, over here, let's find out the magnitude of x. So magnitude of x is given by 4 by 5 square plus 3 by 5 square, which is equal to 16 plus 9 upon 25, which is 1. Similarly, y's magnitude is equal to root of 3 by 8. See, it was under the root whole square plus root 5 upon root 8 whole square. So this is going to give you 3 plus 5 upon 8 under the root, which will be 1. So that means magnitude of x is equal to magnitude of y is equal to 1, right? Also, x into the conjugate is equal to y into its conjugate, and that is equal to 1. So therefore, this given one, this equation can be written as, see, this is x square plus conjugate 1 upon x is actually the conjugate of it. So this can be x square plus the conjugate of x square into y square minus conjugate of y square is equal to x plus its conjugate square minus x plus its conjugate square minus 2x x dash y plus y dash y minus, dash, it's conjugate y minus y plus y conjugate into y minus y conjugate, right? Why? Because you had here y square minus 1 upon y square, which is equal to y square minus y conjugate square, which is a square minus b square form. Hope you got this thing. Now I just have to fill in the values. What was x square? It is equal to 8 upon 5 whole square. See, I'll just solve this first. X square plus okay, I'll pick up the right hand side. So x plus x conjugate whole square. X was equal to 4 by 5 plus 3 by 5 iota plus 4 by 5 minus 3 by 5 iota, because this is the conjugate. They will cancel out and you will have 8 by 5. Similarly, what is, and square, okay, let's leave it right now. And y minus y conjugate square can be written as, it is root 3 by root 8, root 3 by 8 minus root 5 by 8 iota plus root 3 by 8 plus root 5 by 8 iota, which will give you 2 root 3 by 8. Okay, this is the value of y minus y conjugate. And what is y plus y conjugate? This is given by root 3 by 8 minus this. Question number 9, if x is given by this complex number and y is given by this complex number, and you have to find out the value of x squared plus 1 upon x squared into y squared minus 1 upon y squared. You are given x is equal to 4 by 5 plus 3 by 5 iota, and y is root 3 by 8 minus root 5 by 8 iota. Okay, let's find out some values. If I find out, first of all, the magnitude of x, that's equal to 4 by 5 square plus 3 by 5 square, which is equal to root of 16 plus 9 upon 25. That is going to give you 1. Similarly, the magnitude of complex number y is given by root 3 by 8 square plus minus root 5 by 8 square, which will give you 3 plus 5 upon 8, that is equal to 1. Again, that means modulus of x is equal to y is equal to 1. Okay, next, let's find out the conjugate of it. So x conjugate is given by 4 by 5 minus 3 iota upon 5. Y conjugate is given by root 3 by 8 plus root 5 by 8 iota. X plus x conjugate, it will be given by 4 by 5, actually into plus 4 by 5, because minus 3 iota upon 5 and plus 3 iota upon 5, this will cancel. That's going to give you 8 upon 5. Similarly, y plus y conjugate will give you 2 into root 3 upon 8. Similarly, y minus y conjugate, that will give you root 3 upon 8 plus minus root 5 upon 8 iota plus root 3 by 8 plus root 5 by 8 iota. Sorry, this is minus, right? Just a minute, sorry. So this is minus root 3 by 8 minus root 5 by 8 iota. Now this time these two will cancel and you will have minus 2 root 5 by 8 iota. Okay, I hope you got all of these things. One more thing, you know, any complex number multiplied by its conjugate gives you 1. So x into x conjugate is equal to y into y conjugate, and that is equal to 1. Now let's get back to our problem. We needed to find out x plus x square plus 1 upon x square into y square minus 1 upon y square. That is equal to x plus 1 upon x square minus 2 into y square minus 1 upon y. Okay, now this can be written as, I'll pick up the RHS, x plus 1 upon x. This is nothing but x plus x conjugate whole square minus 2 into 1. So x into x conjugate whole multiplied by y square minus y conjugate square. Right. And x plus x conjugate, that is 8 by 5. So 8 by 5 square minus 2. I'll leave it as such. And this is equal to y plus y conjugate into y minus y conjugate. So that is 64 upon 25 minus 2. Y plus y conjugate, it was equal to 2 root 3 by 8. And this one is equal to minus 2 root 5 by 8 iota. Okay. So this is going to give you 14 upon 25 because 25 twos are 50. 64 minus 50 will give you 14. 14 upon 25 into 2 root 3 upon root 8 into this is minus. So this minus will come here. I'll write minus over here. And 2 into root 5 upon 8 iota. Okay. Further solving, this will give you all right. So this is 14 upon 25 minus multiply 2 multiply root of 3 into 5 upon 8 into 8. So this is equal to minus 14 upon 25 into 4 into 15 in the root upon 8. So this 8 will be like this. Okay. So minus 7 upon 25 into root of 15 is the answer to the question. Okay. See, further this can also be solved. So this can be written as 15. I'll take minus 7 into root 3 into root 5 upon this is root 5 into root 5 into 5. One of this will cancel and you will have minus 7 upon 5 into root 3 by 5. So this is the answer to the question. Let's check with the options. You have option A as the answer. Hope you got that. Let's move to the next question, number 10. If x squared minus 5x minus 14 is greater than 0, this where x lies between outside alpha and beta, then you have to find out what alpha upon beta is. I'll pick up the equation x squared minus 5x minus 14 is greater than 0. If this is greater than, let's factorize this. You will have a x squared minus 7x plus 2x minus 14 is greater than 0, which will give you the two factors as x minus 7 and x plus 2 is greater than 0, which makes x is less than minus 2 or x is greater than 7, right? Which means alpha is minus 2 because it's given x lies outside alpha and beta. So alpha is minus 2 and beta is equal to 7. That means minus 2 by 7 is the correct answer. Hope you understood this. Next is question number 11. If x belongs to all the real numbers except 6, then the value of this given expression does not lie in which interval? Okay, you are given x plus 2, x plus 5 upon x plus 6. That's equal to some y. So this can be written as, let's open, x squared plus 7x plus 10 is equal to y into x plus 6, or x squared plus 7 minus y into x plus 10 minus 6y is equal to 0, because all the x belongs to the real numbers. Okay. Now, 7 minus y whole square minus 10 minus 4 into 10 minus 6y is greater than 0, which gives you y squared minus 14y plus 49 minus 40 plus 24y is greater than 0, or y squared plus 10y plus 9 is greater than 0. Let's factorize this again. You will have the two factors will be 9 and 1. This will give you y plus 9. So the two factors are y plus 1 and 9, which gives you y is less than minus 9 or greater than minus 1. So that means y does not belong to -1 to -9. That's it. You have option D as the answer. Hope you got that. Let's move to the next question. I want to clarify one more thing over here. Why I have used this expression? Because x belongs to the real numbers. That means discriminant is greater than 0. Discriminant is given by b square minus 4ac. And this is b, the coefficient of x. The coefficient of x square is a, and this is c. Okay. So 7 minus y whole square minus 4 into 10 minus 6, 5. This should be greater than 0 because x belongs to the real numbers, right? Okay. Next is question number 12. If x is equal to 2 plus this whole expression, then you have to find out this one. Let's go. You're given x is equal to 2 plus 2 raised to power 2 by 3 plus 2 raised to power 1 by 3, or x minus 2 can be written as 2 raised to power 2 by 3 plus 2 raised to power 1 by 3. Let's do the cube on both the sides. So you will have x minus 2 whole cube. This is, let's do the cube on both sides. So you will have a cube, which is 2 raised to power 2 by 3 cube, plus b cube, which is 2 raised to power 1 by 3 cube, plus 3 into a into b into a plus b. Okay, this is gonna give you 2 raised to power 2 plus 2 raised to power 1 plus 3 into, this will be 3 into 2 raised to power 1 again. And let's add that, and this will give you, see, this is equal to x minus 2, right, from here. Got that? So this is equal to 4 plus 2 plus 6 into x minus 2. This is x minus 2 whole cube. Let's split this one also. So this is a cube minus 6x square plus 12x is equal to 6 plus 6x minus 12. Okay. Or this will give you x cube minus 6x square plus 6x is equal to, this will give you 4 over here. Okay, this is minus 6 and plus 8, that's going to give you 2. Okay, so x cube minus 6x squared plus 6x is equal to 2, which is option B. Hope you got that. Let's move to the next question, number 13. The roots of the cubic equation 3x cubed plus 4x squared minus 5x minus 2 is equal to 0 are diminished by h, and a cubic equation with these diminished roots is formed. If the transformed equation does not contain x squared term, then the roots of the transformed equation are, you are given fx is equal to 3x cubed plus 4x squared minus 5x minus 2. Let's factorize this. So the first factor, if I see x is equal to 1 is a root, because see, if I put f of 1, you will have 3 plus 4 minus this, which is equal to 0. And similarly, if I put f of minus 2, this is going to give me 3 into minus 8 plus 4 into 4 minus 5 into minus 2 or minus 24 plus 16 plus 10 minus 2 is equal to 0. This is 26 and 26, that's 0. Okay, I got the two factors as the x minus 1 and x plus 2. So let's find out the third factor now. This will be x square plus x minus 2. Okay, so let's divide them. 3x cubed plus 4x squared minus 5x minus 2, x squared plus x minus 2. So this is 3x squared plus 3x cubed plus 3x squared minus 6x. minus minus plus, this will cancel, and you will have x square plus x minus 2. That's just 1. So this is equal to x square plus x minus 2, or the third factor comes out to be x minus 1, x plus 2. The third factor is 3x plus 1. So this is equal to 3x cube plus 4x square minus 5x minus 2. Okay, that means you have the roots as minus 2, 1, and minus 1 by 3. Now, if the coefficient of x squared in the new cubic is 0, if the coefficient of x squared in the new cubic is 0, then that means the sum of the roots is 0. Sum of roots is 0. How? Sum of the roots is given by minus the coefficient of x squared upon the coefficient of x cube. If the coefficient of x square is not there, that means this is equal to 0. Okay. And what is the coefficient? See, if I'm diminishing that equation by 1, so that new equation will become. See, the original one was 3x cube plus 4x square minus 5x minus 2. If it is diminished by h, so the new equation will be 3 into x minus h cube plus 4 into x minus h square, 5x minus h minus 2 is equal to 0. Right. Now, if the coefficient of x square is equal to 0, then that means the sum is equal to 0, right? First of all, coefficient of x square is equal to 0, which means this is not there, right? And here we have sum of roots is equal to 0. So let's put the different values for x. It was minus 2 minus h plus 1 minus h plus minus 1 by 3 minus h is equal to 0, which will give you minus 1 minus 1 by 3, that is equal to minus 4 by 3 minus 3h is equal to 0, or 3h is equal to minus 4 by 3, which will give you h is equal to minus 4 by 9. So the new roots will become minus 2 plus 4 by 9 minus, 1 plus 4 by 9 and minus 1 by 3 plus 4 by 9. These are the three new roots, which is minus 4 upon 9, 13 upon 9, and 1 upon 9. Hope you got that. So let's check with the options. We have here option C as the answer. Let's move to the next question then. Question number 14, if 0 is less than R is less than S is less than N, and NPR is equal to NPS, then what is the value of R plus S? Let's write, you have NPR is equal to NPS, which means n factorial upon n minus R factorial is equal to n factorial divided by n minus S factorial. N factorials will cancel on both the sides, and you will have n minus R factorial is equal to n minus S factorial. And now you are also given that 0 is less than R is less than N is less than N, which will give you N minus R is greater than N minus S, right? So the only possibility to have this inequality true is when N minus, let's write it down. Only possibility to hold this inequality true is when n minus R is equal to 1 and n minus S is equal to 0. If I look at this one also. So If I get n minus r is equal to 1, I will get r is equal to n minus 1, and n minus s is equal to 0 will give me s is equal to n. Therefore, let's add both of them. R plus s is going to give me 2n minus 1. So this is answer to the question 2n minus 1, option B. Right? Next is question number 15. 3 and 4 digit numbers are formed from these digits 1, 3, 5, 6, 8. If E1 is the number of 3-digit even numbers with no digit repeated. I'll pick up the statements one by one and write down the possibilities. Now, E1 is the number of 3-digit even numbers with no digit repeated. So that means E1, first thing is it's even number. So 3-digit, 1, 2, 3. These are 3 digits. Now, this is got to be even numbers. There are only two even digits over here, that is 6 or 8. So that means you have two choices only over here. If you have two choices, we have 1, 2, 3, 4, 5 numbers. So one digit, sorry, 5 digits. The one digit will be placed at over this place. I'll be left with 4 choices for this and 3 choices for this place. That means E1 can be done in, even event can happen in 3 into 4 into 2, that is equal to 24 ways. Similarly, E2. E2 is a number of 4-digit even numbers with no digit repeated. So that means 1, 2, 3, 4. Again, even numbers, that means here 6 or 8 can come. That means you have two choices over here. If one digit will be filled in this place, I'll be left with 4 choices for this place, 3 choices for this, and 2 for this. All right. So that means E2 event will be 2 into 3 into 4 into 2, which is equal to 48. Okay. Now, next is also O1 represent number of 3-digit odd numbers in which no digit is repeated. So O1 represents 3-digit odd numbers. So that means I can have 1 or 3 or 5. That means I have 3 choices for this place. One digit will be used here. I'll be left with 4 choices for this and 3 for this place. So O1 will be equal to 3 into 4 into 3, which is 36. Okay. Next, O2. O2 represent number of 4-digit odd numbers with no digit repeated. So O2 means 4-digit odd numbers. That means I can have 1, 3, or 5, which will give me 3 choices for this place, 4 choices for this, 3 for this, and 2 choices for this place. That means O2 is equal to 2 into 3 into 4 into 3. That is equal to 72. Right? Now, what do you have to find out? Okay. E1 is equal to 0. E1 is equal to O1 and E2 is equal to O2. No, that's not true. Let's write on E1 all of these. E1 was equal to 24, E2 48, O1 36, and O2 was 72. So option A is wrong. Next, E1 plus E2 plus O1 plus O2 is equal to 5P3 plus P raised to power 3. Let's see this also. Let's add all of them. So E1 plus E2 plus O1 plus O2. This gives me 24 plus 48 plus 36 plus 72. That is equal to 180. And 5P3 plus 5 cube is equal to 5 factorial upon 5 minus 3 factorial plus 5 cube is 125. That gives you 5 into 4 into 3 plus 125, or this is equal to 185. So these two are not equal. That means option B is also incorrect. Let's go with the third one. E1 plus E2 upon 2 is equal to O1 plus O2 upon 3 is equal to 6 square. So the C option, E1 plus E2 upon 2. What is E1? That was 24 plus 48 upon 2. This is equal to 2 and this. So this is equal to 36, and O1 plus O2 upon 3. This gives you 36 plus 72 upon 3. That is 108. So this is 36. Yes, these two are equal. And further, this was said that this is equal to 6 square, which is 36. That means this is equal to 36. That makes option C as the correct answer. Hope you understood this. Next is question number 16. If fn is the coefficient of x raised to power n in the expansion of this expression, then what is the value of f of 2021? You are given that f of n is equal to 1 plus x into 1 minus x raised to power n. I'll keep the 1 plus x and expand 1 minus x raised to power n. This is given by nc0 minus nc1 into x plus nc2 into x square, so on till minus 1 nc n minus 1 x raised to power n minus 1 plus minus 1 x minus 1 raised to power n nc n x raised to power n. Now, I'm just interested in the coefficient of x raised to power n. So when I multiply this with this, one thing, now I'm just looking for the coefficient of x raised to power n, that is equal to 1 multiplied by this term. It will give you minus 1 raised to power n ncn, right, plus, now x when multiplied with this term will give you x raised to power n plus minus 1 raised to power, no, here is not this, okay, plus minus 1 ncn minus 1. That's it. I'll have this, sorry. Yeah. Okay. So minus 1. Here is n minus 1, n minus 1. So this is equal to minus 1 raised to power n. NC n is equal to n factorial upon n factorial into 0 factorial, that is equal to 1. And NC n minus 1 is equal to n factorial upon n minus 1 factorial into 1 factorial, which is equal to n. So this is equal to into 1 plus minus 1 raised to power n minus 1 into n, right? So here you are given, you have to find out f of 2021, which means n over here is 2021, which gives the coefficient becomes minus 1 raised to power 2021 multiplied by 1 minus 1 raised to power 2020 multiplied by n, which is equal to 2021. So this is a odd power. This will return minus 1 plus, and this is even, so this will be 2021 only. The answer will be 2020. So let's check. 2020 is option B. Hope you understood this. I'll like to repeat this thing over here. This was minus 1 raised to power n minus 1. Okay. So that's it. Hope you understood. Next is question number 17. If P and Q are respectively the coefficients of x raised to power minus 3 and x raised to power minus 5 in this expansion where x is greater than 0, then what is the value of 5P upon 4Q? Let's write on the given expression. X raised to power 1 by 3 plus 1 upon 2 x raised to power 1 by 3 whole raised to power 21. You know one thing, TR plus 1 over here is C. This is 21. So this is given by 21 CR into x raised to power R by 3 into 1 upon 2 x raised to power 1 by 3 into 21 minus R. Okay. So this gives you 21 CR upon 2 raised to power. I'll take it this 2 raised to power 21 minus R. 2 raised to power 21 minus R multiplied x raised to power R by 3 into x raised to power 21 minus R upon 3. This gives you what is 21 CR. I'll just write it as such. And this is 2 raised to power 21 minus R whole multiplied by x raised to power 2 by 3. Sorry, this is R by 3 x raised to power r by 3 upon x raised to power 7 minus r by 3. This makes it 21 CR divided by 2 raised to power 21 minus r x raised to power r by 3 minus 7 plus r by 3. So 21 CR 2 raised to power 21 minus r into x raised to power 2r by 3 minus 7. Right? So over here, you have to find out if P and Q respectively the coefficients of this and this. So 17, if P and Q respectively have the coefficients of x raised to power minus 3 and x raised to power minus 5, in the expansion of this, where x is greater than 0, then the value of 5P upon 4Q is equal to. So if you are having any general binomial expansion x plus y raised to power n, the general term is given by NCR into x raised to power n minus r into y raised to power r. So in this expansion, if I take 1 upon 2 into x raised to power 1 by 3 plus x raised to power 1 by 3 whole raised to power 21, like I'll take this as the first and this as the second term for the easy calculations. So over here, you will get the general term, in this case, TR plus 1 will be given by 21 CR into 1 upon 2 x raised to power 1 by 3, 21 minus r into x raised to power 1 by 3 raised to power r. So this can be written as 21 CR into 2 raised to power 21 minus r. Sorry, divided by 2 raised to power 21 minus r into x raised to power minus 1 by 3, 21 minus r x raised to power 1 by 3 raised to power r. This is 21 CR upon 2 raised to power 21 minus r into x raised to power. This is going to give me r upon 3 minus 7 plus r upon 3. Bases are same, powers will add. So this is equal to 21 CR upon 2 raised to power 21 minus r into x raised to power 2r upon 3 minus 7. Now you are interested in the coefficients of x raised to power minus 3 and x raised to power minus 5. So for x raised to power minus 3, for x raised to power minus 3, 2r upon 3 minus 7 is equal to minus 3, which gives you 2r upon 3 is equal to 4, or r will be equal to 6. For x raised to power minus 5, 2r upon 3 minus 7 is equal to minus 5, which gives you 2r upon 3 is equal to 2, or r will be equal to, that's equal to 3. Okay, so you got the value for r in case of x raised to power minus 3 and x raised to power minus 5. Now I'm interested in the coefficients because p is the coefficient of x raised to power minus 5. In that case, r came out to be 6. So this makes the coefficient as 21c6 upon 2 raised to power 21 minus 6. Okay, I'll leave it as such right now. And q is equal to coefficient. Sorry, here was 3. Okay, coefficient of x raised to power minus 5. And in this case, r was equal to 3. So 21c3 upon 2 raised to power 21 minus 3. This gives you, I'll just write like this only. And this is 2 raised to power 15. And this is 21c3 upon 2 raised to power 18. What you have to find out? 5p upon 4q. So 5p upon 4q is equal to 5 upon 4. P was equal to 21c6 and q was equal to 21c3 multiplied by 2 raised to power 15 will come over here and 2 raised to power 18 will go up. So that's going to give you 5 upon 4 into 21 factorial upon 6 factorial into 15 factorial multiplied by 21 factorial into 3 factorial into 18 factorial multiplied by 2 raised to power 18 minus 15, that is 2 raised to power 3. So this is equal to 5 upon 4. These two will cancel out and you will have 18 into 17 into 16 into 15 factorial whole multiplied by 3 into 2 into 2 raised to power 3. And denominator will have 15 factorial into 6 factorial. Let's open this. 6 into 5 into 4 into 3 into 2 into 1. So let's solve it now. You will have these two cancellations, and 6 3s are 18 will cancel. 4 will cancel here, and this 4 will cancel this. Then you have 3 2. Okay, this 2 will cancel at this place, and this 5 will cancel this thing. You are left with 17 into 3 into 8. That is equal to 408. Okay, so this is the answer to the question. 408 is option B. Hope you understood this. Let's move to the next question. 18 for n p belonging to natural numbers except 1, the coefficient of x raised to power 3 in this is equal to. See, the bases are same. So I can write down this expression as 1 minus x raised to power 1 minus p minus n, which will give you 1 minus x raised to power minus np minus 1 upon p, right? So I'll put this thing minus np minus 1 upon p. I'll put this is equal to some k. Okay, now when I put this into k, what does this expression become? This becomes 1 minus x whole raised to power k. And let's expand it now. You will write it as 1 minus k into x plus k into k minus upon 2 into x square plus, minus k into k minus 1, k minus 2 upon 6 into x cube and so on. See, in the question, I'm only interested in the coefficient of x cube, so I'll pay my whole attention towards this. Coefficient of x cube is equal to minus k into k minus 1 into k minus 2 upon 6. So what was the value of k? It was minus np minus 1 upon p. So that is equal to minus 1 upon 6 minus np minus 1 upon p minus np minus 1 upon p minus 1. That's equal to this. So I'll keep this as such. Minus np minus 1 minus p upon p, which makes it. Okay, I left over here one thing, minus np minus 1 minus p minus 2 as well. So this is equal to minus np minus 1 minus 2p upon p. Now this will be, let's multiply, this will be 1 minus 1 upon 6p cube. And I'll take the minus common from all of them. So minus 1 will be taken from here, minus 1, minus 1. So this will become plus 6, 1 upon 6 raised to power, I'll rewrite this. So this is equal to minus 1 upon 6p cube into minus 1 whole raised to power 3. 1 plus np, 1 plus p plus np, and this is 1 plus 2p plus np. Okay, that's it. Now let's write it properly. This is equal to 1 upon 6 p raised to power 3 into np plus 1 into np plus p plus 1 into np plus 2p plus 1. Let's see which is the correct option out of these. You have option A as the correct answer. 3 factorial, see, this is equal to 6 only. Okay, so that means you have option A as the correct answer to the question. Hope you understood this. Let's move to the next question, number 19. Question number 19, if 1 upon x minus 1 into x minus 2 into x minus 3 is equal to a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3, and x upon this whole thing is equal to this whole thing. Then what is the value of A plus 2B plus 3C? I'll start with this one. So you are given 1 upon x minus 1 into x minus 2 into x minus 3 is equal to A upon x minus 1, B upon x minus 2, C upon x minus 3. So this can be written as, I'll take the LCM. So x minus 1 into x minus 2 into x minus 3, A into x minus 2 into x minus 3 plus B into x minus 1 into x minus 3 plus C into x minus 1 into x minus 2. This is equal to 1 upon x minus 1 into x minus 2 into x minus 3, which gives you 1 is equal to A into this plus B plus C. Okay. So now here, when I put x is equal to 2, you get B's value. See, x is equal to 2, so this will be 0 and this will be 0. And B's value will come out to be minus 1. Okay. And when I put x is equal to 3, so this and this will be 0 and you will get the value of C is equal to 1 by 2. You can solve it. See over here. So when I'm putting x is equal to 3, this will be C into 2 into 1 is equal to 1, or 2C is equal to 1, which will give you C is equal to 1 by 2. So further, when I put x is equal to 1, then these two terms will equate to 0 and you will get the value of A as 1 by 2 again. Let's write down the values. You got A as 1 by 2, B as minus 1 and C as 1 by 2 again. Now let's move to the second pair, this one. So you are given x upon x minus 1, x minus 2, into x minus 3 is equal to P upon x minus 1, Q upon x minus 2, R upon x minus 3. This is equal to x minus 1, x minus 2, x minus 3, P into x minus 2, x minus 3, plus Q into x minus 1, x minus 3, R into x minus 1, x minus 2. This is equal to x upon x minus 1, 2, and 3, which gives you x is equal to P into x minus 2, x minus 3, Q, x minus 1, x minus 3, R, x minus 1, x minus 2. Now let's put the different values of x. When I put x is equal to 2, when x is equal to 2, so this and this will become 0 and you will find out the value of Q to be minus 2. When you put x is equal to 3, you will find out that the R's value is 3 by 2. And when you put x is equal to 1, you will get P as 1 by 2. So let's write down the values. P is equal to 1 by 2. Q is minus 2 and R is 3 by 2. What you had to find out was this. A plus 2B plus 3C. Okay. So I'll solve it here only. You had to find out A plus 2B plus 3C, that is 1 by 2 plus 2 into minus 1 plus 3 into 1 by 2, which gives you 1 by 2 minus 2 plus 3 by 2, which is equal to 0. Okay. Now this is equal to, you have to find out different relations with all of these options. I have to check with this. So let's go with the first one, P plus Q plus R. P plus Q plus R, 1 by 2 minus 2 plus 3 by 2. This is of course 0. So that's good. We got our first option to be correct. A plus 2B plus 3C is equal to P plus Q plus R, which makes option A to be the correct answer. Hope you got this. Next is question number 20. 2 sine raised to power 6 theta plus cos raised to power 6 theta minus 3 sine raised to power 4 theta plus cos raised to power 4 theta is equal to what? So in this question, I'll first of all, to answer the question, I would like to discuss a formula, that is a cube plus b cube. This is given by a plus b multiplied by a square plus b square minus ab, or sine square theta whole raised to power 3. So this can be written as cos square theta. Sorry, not this. I'll discuss this later. Okay, so sine square theta whole raised to power 3 plus cos square theta whole raised to power 3 will be equal to sine square theta plus cos square theta. I'm using this identity multiplied by sine raised to power 4 theta cos raised to power 4 theta minus 2 sine square theta cos square theta. So, this is equal to 1. This is 1 multiplied by sine raised to power 4 theta plus cos raised to power 4 theta minus 2 sine square theta cos square theta. This thing further, I'll fill in this expression. So you have 2 into sine raised to power 4 theta. This is equal, see, this was equal to sine raised to power 6 theta plus cos raised to power 6 theta. So this is 2 into sine raised to power 4 theta plus cos raised to power 4 theta minus 2 sine square theta cos square theta minus 3 sine 4 theta plus cos raised to power 4 theta, which on opening will give you minus 4. That's going to give you, okay, that's going to give you minus 4 sine square theta cos square theta, and that is equal to minus sine raised to power 4 theta minus cos raised to power 4 theta. Okay. See, there is a mistake. I think this 2 I have written by mistake. So there is no 2 over here, and this will be 2 only. Okay. All right. So now let's sit. Finally, this is minus sine raised to power 4 theta minus cos raised to power 4 theta minus 2 sine square theta cos square theta, which is equal to minus of this plus this plus this, right? And this is equal to minus sine square theta plus cos square theta whole square, that is equal to minus 1. So the value of this expression is equal to minus 1. Option A. Hope you understood this. Next is question number 21. It says sine 35 upon cos 55 whole square plus cos 55 upon sine 35 whole square minus 2 cos 30 degree is equal to. It's a pretty easy question. You just have to know the trigonometric ratios of the complementary angles. You know one thing, sine 90 minus theta is equal to cos of theta. So do remember this thing. I'll be using the same formula or identity in this question. So if I say theta is equal to 45, this means sine 55 is equal to, sorry, sine 35 is equal to cos 55. And if I take this over here, in this case, if I take theta is equal to 35 degree, this gives you sine 55 degree is equal to cos 35 degree. So I'll use in this question, now this particular expression becomes sine 35, that's equal to cos 55 upon cos 55 whole raised to power 2 plus cos 55 upon, cos 55 upon sine 35. So sine 35 is equal to, wait, this is Question number 21. Sine 35 upon cos 55 whole square plus cos 55 upon sine 35 whole square minus 2 cos 30 degree is equal to. In this question, this is a pretty easy question. Actually, I'll have to use the trigonometric ratios of the complementary angles, which is sine 90 minus theta is equal to cos of theta. So if I say theta is equal to 55 degree, then sine 90 minus 55, that is sine 35 is equal to cos 55. Also, if I say theta is equal to 35 degree, this gives you sine of 90 minus 35, that is 55 degree, is equal to cos of 35 degree. Okay, I'll get to this expression. This gives you sine 35 can be written as cos 55 upon cos 55 whole square plus cos 55 upon sine 35 can be written as cos 55 whole square minus 2. Cos 30 is equal to root 3 by 2. That's equal to 1 square plus 1 square minus root 3. This is going to give you 2 minus root 3. So pretty easy question. Option B is the correct answer. Hope you got that. Let's move to the next question then. Question number 22. If cos theta is minus 3 by 5 and theta lies between pi and 3 pi by 2, that means theta is in the third quadrant. You have to find out tangent of theta by 2. Okay, cos theta is minus 3 by 5 where theta lies in the third quadrant. Right? And I have to find out tangent of theta by 2. Tangent of theta by 2 can be written as sine theta by 2 upon cos theta by 2. Let's multiply numerator and denominator by multiply numerator and denominator by 2 cos theta by 2. This will be tangent of theta by 2 to sine theta by 2 cos theta by 2 upon cos square theta by 2. This gives you sine theta and cos square theta by 2. Sorry, I missed 2. 2 cos square theta by 2 is the formula for 1 plus cos theta. Okay. One thing, if I don't know the value of sine theta. Let's find out first of all sine theta. I'll find it here. Sine theta is root of 1 minus cos square theta. That is, it is root of 1 minus this. That is 25 plus 9 upon 25 root, which is, okay. That is equal to, sorry, here is not plus, here is minus. -25 minus, this is minus 3 square is 9 upon 5, 25. That is 16 upon 25, which is equal to 4 by 5. So this is the value for sine theta. That means tangent theta by 2. Now this will become 4 by 5 upon 1 plus 3 by 5. So this is 4 by 5 upon 8 by 5, which will give you 1 by 2. Okay. Question number 22. If cos theta is equal to minus 3 by 5 and theta lies between pi and 3 pi by 2, then tangent theta by 2 is equal to what? Theta lies in the pi and pi, between pi and 3 pi by 2. That means theta is in the third quadrant. And you have to find out tangent of theta by 2. So tangent of theta by 2 can be written as sine theta by 2 upon cos theta by 2. Let's multiply the numerator and denominator by 2 cos theta by 2. So this becomes 2 sine theta by 2 cos theta by 2 upon 2 cos square theta by 2, which is sine theta upon 1 plus cos theta. right? I don't know the value for sine theta. Let's find out sine theta. So sine theta will be is given by root of 1 minus cos square theta, 1 minus 3 by 5 whole square. That is 1 minus, sorry, 25 minus 9 upon 16, which 25 upon 25, which is 16 upon 25, that is 4 upon 5. Now theta lies in the fourth quadrant. That means sine theta will be minus 4 by 5 because sine is negative in the third quadrant. Okay. Sorry, theta lies in the third quadrant. Sine theta is negative because sine is negative in the third quadrant. So tangent theta, which was sine theta upon 1 plus cos theta, is equal to sine theta is minus 4 by 5, 1 plus minus 3 by 5. This is minus 4 by 5 upon 2 by 5, or minus 2 is the answer. That means we have option B as the correct answer. Hope you got that. Next is question number 23. It says 1 minus tan square 15 upon 1 plus tan square 15. Okay, this, let's split it. You can write it as 1 minus sine square 15 upon cos square 15 whole divided by 1 plus sine square 15 cos square 15. So this is cos square 15 minus sine square 15 upon cos square 15 plus sine square 15. This is, see, this is sine square a plus cos square a. This is equal to 1. So you'll be left with cos square 15 degree minus sine square 15 degree, which is cos 15 into cos 15 minus sine 15 into sine 15. This is the formula for cos A cos B minus sin A sin B. This is the formula for cos 15 plus 15, that is cos 30, and this is root 3 by 2. You know this. That means option C is the correct answer. Hope you understood. Next is question number 24. If 6 cos 2 theta plus 2 cos square theta by 2 plus 2 sin square theta is equal to 0, where theta lies between minus pi to pi. That means, okay, it lies between minus pi to pi. It is in the first and the second quadrant. Then theta is equal to, you are given 6 cos 2 theta plus 2 cos square theta by 2 plus 2 sin square theta is equal to 0. I can say this. Cos 2 theta can be written as 2 cos square theta minus 1 plus 1 plus 2 cos square theta by 2 is the formula for 1 plus cos theta, and 2 sin square theta can be written as 2 1 minus cos square theta is equal to 0. So let's open. This is 6 2 cos square. Let's open this 2 cos square theta minus 1 plus 1 plus cos theta plus 2 minus 2 cos square theta is equal to 0. So this will cancel, and you will have 6 into question number 24. If 6 cos 2 theta plus 2 cos square theta by 2 plus 2 sin square theta is equal to 0, where theta lies between minus pi to pi, then you have to find out the value of theta. You are given that 6 cos 2 theta plus 2 cos square theta by 2 plus 2 sin square theta is equal to 0. So cos 2 theta can be written as 2 cos square theta minus 1, and 2 cos square theta by 2. This is 1 plus cos theta. 2 sin square theta. This is equal to 2 into 1 minus 2. Sorry, 1 minus cos square theta. That is equal to 0. This makes it 12 cos square theta minus 6 plus 1 plus cos theta plus 2 minus this is equal to 0. That is 10 cos square theta plus cos theta minus 3 is equal to 0. Now, this is a quadratic equation. Let's split the middle term. So, 10 cos square theta plus 6 cos theta minus 5 sine, cos theta minus 3 is equal to 0. I'll take 5 this side. So 10 cos square theta minus 5 cos theta plus 6 cos theta minus 3 is equal to 0. 5 cos theta, that gives you 2 cos theta minus 1 plus 3 2 cos theta minus 1. So the two factors are 5 cos theta plus 3. 2 cos theta minus 1 is equal to 0. So that gives you cos theta is equal to 1 by 3 or cos theta is equal to minus 3 by 5. As theta is lying between minus pi and pi. So theta is equal to, this is equal to cos of pi by 3. Okay. So theta is equal to plus minus pi by 3 or plus minus. See over here theta, it is theta pi minus cos inverse. From here you have theta is equal to cos inverse minus 3 by 5. This will be minus will be taken outside over here. So minus cos inverse 3 by 5. This is the value for theta. That is option T. Hope you understood. Next is question number 25. Sine of tan inverse 4 by 5 plus tan inverse 4 by 3 plus tan inverse 1 by 9 plus tan inverse 1 by 7 is equal to. So here you have a sine of, I'll write, concatenate some terms, tan inverse 4 by 5 plus tan inverse 1 by 9. Tan inverse 4 by 3 minus tan inverse 1 by 7. Okay, give me a minute. Yes. So this is equal to sine of, this is tan inverse A plus tan inverse B. This can be written as tan inverse 4 by 5 plus 1 by 9. Wait. Tan inverse 4 by 5 plus 1 by 9 upon 1 minus 4 by 5 into 1 by 9 plus tan inverse 4 by 3 minus 1 by 7 upon 1 plus 4 by 3 into 1 by 7. So this makes sine of, not sine inverse, sine of tan inverse 36 plus 5 upon 45 minus 4. Tan inverse 28 minus 3, 21 plus 4. Sine of tan inverse this plus this, which is sine of tan inverse 1. This gives 2 tan inverse 1. Right? Okay, no, I'll write it openly before. This is not sine inverse, sorry. Sine of tan inverse 1 plus tan inverse 1. Okay. Now this is equal to sine of tan inverse 1 is pi by 4 plus pi by 4. So this is 2 pi by 4 or sine of pi by 2, that is equal to 1. You know sine pi by 2 is equal to 1. That means option D is the correct answer. Hope you got that. Let's move to the next question number 26. Let k is greater than 0 and t is secant h inverse 1 by 2 minus cosecant h inverse 3 by k. If 3 e raised to power t is equal to 2 plus root 3, then k is equal to. Okay, one thing you know, secant h inverse x is log of 1 plus root of 1 minus x squared upon x. So if I take x is equal to 1 by 2, this becomes secant h inverse 1 by 2 is equal to log of 1 plus 1 minus 1 by 4 upon 1 by 2, which is log of 1 plus root 3 by 2 upon 1 by 2. This will be log of 2 plus root 3. Now I'll move to this. Cosec h inverse x, this is equal to log of 1 plus x squared upon x. And I have to find it for 3 by k. So let's fill natural log. This is equal to 1 plus 1 upon 9 plus k squared upon 3 by k. That's equal to log of k will be taken outside. So this is k plus k squared plus 9 upon 3. Because the k from the numerator and the denominator will cancel out. Okay. Hope you got this. Now you have to subtract both of them. So secant h inverse 1 by 2 minus cosecant h inverse 3 by k is equal to natural log 2 plus root 3 minus this k plus k squared plus 9 upon 3. That is equal to some t, right? It's given. So this becomes log of 2 plus root 3 divided by k plus root of k square plus 9 whole multiplied by 3 is equal to k. T, sorry. This makes 3 into root 3 plus 6 upon k plus root of k squared plus 9 is equal to e raised to power t, which makes it 3 root 3 plus 6 is equal to e raised to power t into k plus root of k square plus 9. Right? So 3 root 3 plus k is equal to e raised 3 e raised to power 3 was equal to this. I'll fill in the value over here. So that's equal to k plus root of k square plus 9 multiplied by 2 plus root 3 upon 3. Okay. You have to find out k's value in this case. So I'll try to put different values. If I put k is equal to 1, then LHS 3 root 3 plus 1. And what about the RHS? This will be equal to 1 plus root of 10 into this. Of course, these two terms, they are not equal. I'll have to pick up a bigger term. Let's try for k is equal to 4. K is equal to 2 was in the option. So let's try for k is equal to 2 now. This will become 3 root 3 plus 2 LHS. And the RHS is 2 plus root of k square, that is 13 into 2 plus root 3 upon 3. This is not equal. Let's go for k is equal to 4 now. This B option. This is 3 root 3 plus 4. Sorry, there is 6 over here. And still they are not equal. So 3 root 3 plus 6. This should be equal to RHS says that is equal to k plus root of k is 4 plus root of 4 square is 16. 16 plus 9 is 25. 25. I'll write down 25 over here. 2 plus root 3 upon root 3. This is equal to 9 into 2 plus root 3 upon 3. That is 3 into 2 plus root 3, which is 6 plus 3 root 3. So here both are equal. That makes option B to be the correct answer. Hope you got that. Then let's move to the next question, number 27. In a triangle ABC, 4A is equal to B plus C. Then you have to find out tangent B by 2 into C by 2. Okay. So tangent of B by 2 into tangent of C by 2. This can be written as root of S minus A into S minus C upon S into S minus B, multiplied by S minus A into S minus B divided by S into S minus C. So let's concatenate them. S minus A, S minus C, S minus A, S minus B whole divided by S into this into this. So this is gonna cancel and this is gonna cancel. You will be left with S minus A upon S. This is the value of tan B by 2 into tan C by 2. Okay. Okay. So, S is equal to semi-perimeter, that is A plus B plus C upon 2. So here you are given that 4A is equal to B plus C. So this gives you 5A upon 2. This is the value of S. That means S minus A upon S becomes 5A upon 2 minus A upon 5A upon 2. This gives you 3A upon 2 upon 5A upon 2. That is equal to 3 by 5. So the answer to the question is 3 by 5 and option B. Hope you got that. Let's move to the next question then. Question number 28 says 4 times the area of the square of a triangle. 4 times the area of a triangle of ABC is C squared minus A minus B whole square. Then what is sine C is equal to? 4 times area of the triangle ABC is given by C square minus A minus B whole square. Area is given by half into, it can be written like A into B into sine C. This is equal to C square minus A square minus B square plus 2AB. Or sine C can be written as 1 minus A square plus B square minus C square upon 2AB, right? Next, this gives you sine C is equal to 1 minus, now this is the formula for cos C, which gives you sine C plus cos C is equal to 1, right? Sine C plus cos C equal to 1. So this can be written as how to solve this? Let's multiply. Multiply and divide. Okay, multiply. Okay, multiply both sides by root 2. Okay, so what will you get is root 2 into sine C plus cos C is equal to root 2, or you can write it as sine C into 1 by root 2 plus cos C into 1 by root 2, this whole multiplied by this is equal to 1. 1 by root 2 is sine pi by 4. And 1 by root 2 is also equal to cos pi by 4, right? Question number 28, if 4 times the area of the triangle ABC is this, then what is the value for sine C? Okay, you are given that 4 times the area of the triangle is C square minus A minus B whole square. That means 4, area is given by half into AB sine C, if I have to involve sine C. So this is given by C square minus A square minus B square plus 2AB, right? Or sine C This is equal to 2ab sine c is equal to c square minus a square minus b square plus 2ab. Here sine c will be equal to 1 minus a square plus b square minus c square upon 2ab, right? Now, this is the formula for cos c. So, sine c is equal to 1 minus cos c, or sine c plus cos c is equal to 1. Now, how do I solve this thing? I have to multiply and divide the numerator and the denominator by root 2. Multiply and divide numerator and denominator by root 2. You will have root 2 into 1 by root 2 sine c, 1 by root 2 cos c is equal to 1. That makes sine c 1 by root 2 can be written as cos pi by 4 plus 1 by root 2 can be written as sine pi by 4 into cos c is equal to 1 by root 2. This is the formula for sine A cos B plus sine B cos A. That means this is equal to sine C plus pi by 4. Now, 1 by root 2, this can be written as pi by 4, sine pi by 4, which gives you C plus pi by 4 is equal to pi by 4, or C is equal to 0. But this is not possible because C is the angle of the triangle ABC. That means you can't have sine pi by 4 over here, which simply means sine C plus pi by 4 will be equal to 3 pi by 4. Okay, so this is lying over here 3 pi by 4. That means C plus pi by 4 is equal to 3 pi by 4, or C will be equal to minus this, or that's equal to C is equal to pi by 2. That's it. C is equal to pi by 2. I have to find out sine C. So sine of pi by 2 is equal to 1, which makes option A to be the correct answer. D to be the correct answer. Hope you understood this. Next is question number 29. If cot in a triangle ABC, if cot A by 2, cot B by 2 is equal to K, then all the possible value of K lies in your given cotangent A by 2, B by 2 is equal to K. Cotangent A by 2 is given by S into S minus A upon S minus B, S minus C multiplied by S into S minus B into divided by S minus A, S minus C whole raised to power 1 by 2, that's equal to 2 because they are under the root. So you will have this will cancel out and this will cancel. You will have S upon S minus C is equal to K. Now, what is S? That is equal to A plus B plus C upon 2. And S minus C is A plus B minus C upon 2. So 2 and 2 will get cancelled and you will be left with this. This will be A. I can write it as A plus B minus C plus 2C upon A plus B minus C is equal to K, or that's equal to 1 plus 2C upon A plus B minus C is equal to 0. Now, in any triangle, A plus B, the sum of two sides is always greater than the third side. So, 2C upon A plus B minus C is always greater than 0. Therefore, K will belong to 1 to infinity. Okay. That means you have option C as the correct answer. Hope you got that. Let's move to the next question, number 13. A triangle ABC, B square sine 2C plus C square sine 2B is equal to. This can be written as, let's write it down, 2b square sine 2c. So this is, I can write it like this, b square into 2 sine c cos c plus c square into 2 sine b cos b. I'll take 2 common. So this makes b square sine c cos c, c square sine b cos c. Now you know one thing, a upon sine a is equal to b upon sine b, c upon sine c. That's equal to 2r, which is ABC upon 2 times the area of the triangle. Now, let's get back to where we were. That's 2 into b square sine c into cos c. This can be written as 2 delta upon AB into a square plus b square minus c square upon 2ab plus c square into 2 delta upon AC multiplied by a square plus c square minus b square upon 2ac. I'll take common now. You will have 2 delta. First of all, this will cancel. Okay, 1c and this c, 1b and this b. And I'll take 2 delta outside. Inside will be a square plus b square minus c square upon, okay, this b will also cancel and this a will cancel. Sorry. This c will cancel. Okay. And over here, the denominator will be a square plus c square minus b square upon a square. That is equal to 2 delta. Denominators are same. So you will have a square plus b square minus c square, a square plus c square minus b square whole divided by a square. By b square and c square will cancel. You will have 2 delta into 2a square upon a square, which is equal to 4 delta. So the answer to the question is option B. Hope you got that. Let's move to the next question then. Question number 31. The position vector of the point P and Q respectively are this and this. The ratio in which the point having the position vector this divides a line segment which is joining P and Q is, you are given the point. See, the position vector for the point is P is this and Q is this. Therefore, P point can be given by -2, -3 and K, and Q 3, 3 and 2. Now let's say this point divides PQ in the ratio lambda is to 1. Let the required ratio is lambda is to 1, which gives you the point RS. See, this is the point P and this is the point Q, and this R is the point which is dividing it in the ratio lambda is to 1. So R will be given by lambda into 3, that is 3 lambda minus 1 into -2, that is -2 upon lambda plus 1, comma 3 lambda minus 3 upon lambda plus 1, 2 lambda plus 1 upon lambda plus 1. Now this is equal to, this is the position vector. So that means this is equal to -9/2, -6 and 1/2, which gives you 3 lambda -2 upon lambda plus 1 is equal to -9/2, or you will have 6 lambda minus 4 is equal to -9 lambda -9, or 15 lambda is equal to -5, which gives you lambda is equal to -1/3. Right. That means the required ratio is -1/3 is to 1, or -1 is to 3. That is option D is the correct answer. Hope you understood this. Next is question number 32. Now again, a vector problem. Consider the vectors A and B. These are the two vectors A and B. And C, three vectors. If L, M, N are the length of projections of A on B on C, and C on A, respectively, then which of the following is true? So in this question, you are given that L is a projection of A on B. That means L is equal to A into B cap. And M is the projection of B on C. So this is equal to B into C cap. And N is the projection of C on A. So this is equal to C into A cap. Which means L can be written as 3, 5, 2 multiply B cap. Now B cap is 2 minus 3 minus 5 whole divided by root of 2 square, which is 4 plus 9 plus 25, which is equal to 3 2s are 6 minus 15 minus 10 whole divided by that's equal to root of 38. Okay, so this gives you minus 19 upon 38. That's L. Let's go for M. So M is 2 minus 3 minus 5 dot minus 5 minus 2 and 3 whole divided by root of 25 plus 4 plus 9. That will give you minus 10 plus 6 minus 15 upon root of 38. That's again minus 19 upon root of 38. Same thing. Now let's go for N. Finding N. N is given by minus 5, minus 2, and 3. This is in the dot product 3, 5, and 2 whole divided by root of 9, 3 square 9, 5 square 25, 2 square is 4. So that is equal to minus 15 minus 10 plus 6 upon root of 38, which again gives you minus 19 upon root of 38. Okay, this is what, fine. Then you have to find out which of the following is true. L plus M minus N is equal to 0. Since C, all the three are equal, so this is wrong. Yes, option B is correct. All the three are equal. That means we have our answer as option B. Hope you got that. Next is question number 33. Let xy belong to real number into real number. A is given by this, B is given by this. These are the two vectors. And A cross B whole square plus A dot B whole square is equal to fx into gy. Then fx plus gy minus 46 is equal to 0. It represents what? A pair of lines, ellipse, hyperbola, or a circle. Okay, you are given that see, A vector, the direction ratios are given by x, 2, and minus k. For B, it is 6, minus y, and 2. Question number 33. Let xy belong to R into R. If A is given by this, B is given by this, be the two vectors, then if A cross B whole square is plus A dot B whole square is equal to fx into gy, then fx plus gy minus 46 is equal to 0 is represents what? A pair of lines, ellipse, hyperbola, or a circle. Okay, let's write it down. You have the two vectors. First one is A. The direction ratios can be given by x, 2, minus 1, and B can be represented 6, minus y, and 2. Right. Now you're given if A cross B whole square plus A dot B whole square is equal to fx into gy. That means this is C. A cross B whole square, this is A square, magnitude of B square into sine square theta plus magnitude of A square B square plus cos square theta. This is fx into gy. Sorry, this is fx into, yes, this is fx into gy. So I'll take this common. Sine square theta plus cos square theta is fx gy, which gives you magnitude of a square into b square is equal to this. Right. A was equal to, let's find out the magnitude of a square. This is equal to x square plus 4 plus 1 into, this is 6 square, 36 plus y square plus 4 is equal to fx into gy. That's x square plus 5, and this is y square plus 40 is equal to fx into gy, which makes fx is equal to x square plus 5 and gy is y square plus 40. You have to find out fx plus gy minus 46 is equal to 0. Fx plus gy minus 46 is equal to 0. This is x square plus 5, y square plus 40 minus 46 is equal to 0. This gives you x square plus y square is equal to 1. This is the equation of a circle for sure. Okay. That means we have option D as the answer. Hope you got that. Next is question number 34. If A vector is represented by this and the magnitude of B vector is 6, angle between A and B is pi by 6, then the area of the triangle in square units with A and B as two of its sides is. You have to find out area, right? Area of the triangle is half into, like two sides are given to you, A magnitude, B magnitude into sine of the third angle, like the third C angle, sine of the third angle. Now, if I put, it's given that the angle between them is, angle between A and B is pi by 6, right? So, C is equal to pi by 6, which gives you area is equal to half of. Magnitude of A is given by root of 2 square plus 2 square plus 1 square. That is 4 plus 4 plus 1 into magnitude of B square is, it's given to be 6. Okay, so I'll not find it. So that's 6 into sine of pi by 6, which gives you half into 3 into 6. Sine pi by 2 is 1 by 2. So that is equal to 9 by 2. That's it. Option D is the correct answer. Hope you understood. Next is question number 35. If R is a vector perpendicular to both of these two vectors and satisfies this equation, then what is the magnitude of R vector? Okay, so R vector is given by, since it is perpendicular to both of these vectors, so R is equal given by lambda into I, J, K matrix. And here will be 2, 3, minus 4, 3, minus 1, K. Oh, sorry, K is, sorry, not K1. Right? So let's find out the magnitude. This is given by lambda into minus I cap minus 14 J cap minus 11 K cap. Let's solve it also. Okay. So I cap 3 plus 4, 3 minus 4. Minus J cap 2 plus 12 plus K cap minus 2 minus 9. So that gives you lambda is equal to minus I cap minus 14 J cap and minus 11 K cap. Right, now this is given that this is equal to this. R dot I minus 3J plus 4K. Now this is given to you equal to 5. This is equal to 5, which means lambda into minus I minus J minus 11K 3I 3J plus 4K is equal to 5, which gives you lambda is equal to 3 into minus 1, this will be minus 3. 14 minus 14 minus 3 will be plus 42 minus 44 is equal to 5. So lambda multiply minus, that is equal to minus 5 is equal to 5, which gives you lambda is equal to minus 1. So magnitude of R is lambda into 1 plus, see over here, yeah, that one. So 14 square is 196, 11 square is 121. So that is 196 plus 191. I'm using this equation. So that's equal to, lambda was minus 1. Mod of it, it will give me 1 multiplied by root of, that is 318. So magnitude of R vector is equal to root of 318. This is option C. So this is the correct answer. Hope you got that. Let's move to the next question then. Question number 36. The perpendicular distance from the origin to the plane containing the points having the position vector this and this and this is. So you're having the points. Let's name this as P, this one as Q, this one is R, and let there be one more point, X, with the direction ratios, vector actually, P with the direction ratios X, Y, Z. So the line PQ will have the direction ratios as 2 minus 1, 1, 3 minus 2, 1, minus 4 minus 3, that is minus 7. And Q minus QR will have the direction ratios of 3 minus 2, that is 1, minus 4 minus 3, that is minus 7. And 5 plus 4, 9. Now, PT will have the direction ratios as X minus 1, Y minus 2, Z minus 3. Now it's given that PQ and QR and PT, they are coplanar. They are in the same plane. That means their determinant is equal to 0 if written in the matrix form. So let's write down then in the matrix form, X minus 2, Y minus 2, Z minus 3, and 1, 1, 7, minus 7, 1, minus 7, and 9. The determinant is equal to 0. Let's open up. So here you have X minus, wait, here is X minus 1, not 2. X minus 1, 9, minus 49, minus Y minus 2, 9 plus 7 plus Z minus 3, minus 7 minus 1 is equal to 0, which gives you 40, minus 40, X minus 1 minus 16, Y minus 2 minus 8, Z minus 3 is equal to 0. Or 40x plus 16y plus 8z is equal to 96. Therefore, the distance from the origin from 0, 0, 0 will be given by modulus of magnitude of 0 plus 0 plus 0 minus 96, because when I'll take 96 on the LHS, it will be minus 96 whole divided by 40 square plus 16 square plus 8 square. That is equal to 96 upon 8 root 30, which is 12 upon root 30. So this is the answer to the question, 12 upon root 30. That is option B. Hope you got that. Next is question number 37. Let O be the mean deviation of the first 5 odd natural numbers about their mean, and P be the mean deviation of the first 5 prime numbers about their mean. Then P minus O is equal to. Okay, so first of all, let's consider this odd number thing. First 5 odd numbers are this, and mean of them. Mean of first 5 odd numbers is 1 plus 3 plus 5 plus 7 plus 9 whole divided by 5, which is equal to 5. So the deviations will be see, deviations will be 5 minus 1, that is equal to 4. I'm taking the mod of it. 5 minus 3, that is 2, 0, 2, and 4. Okay, I hope you know this thing, right? 5 minus 1 will give you 4. Then 5 minus 3 will give you 2. 5 minus 5, 0. 5 minus 7, that is minus 2. I'm taking the mod of it. So minus 2 mod is 2. And similarly, 5 minus 9 mod is 4. Okay. All right. Now, O is the mean deviation of first 5 odd numbers. So O is mean deviation. So that is equal to 4 plus 2 plus 0 plus 2 plus 4 whole divided by 5. That is equal to, it is 6 and 6. So that is 12 upon 5, right? Okay. Now, let's take first 5 prime numbers. This is equal to 2.4. So first 5 prime numbers are 2, 3, 5, 7, and 11. Now let's find out their mean. It is 2 plus 3 plus 5 plus 7 plus 11 whole divided by 5. That is equal to 10 and 18. That is equal to 28 upon 5, which is equal to 5.6. This is the mean. Now let's go for the deviation. Deviation is given by 5.6 minus 2, which is 3.6. 5.6 minus 3, that is equal to 2.6, 0.6, comma 1.4, and 5.4. So this is the deviation. Now mean deviation, P is mean deviation, which is 3.6 plus 2.6 plus 0.6, 1.4, 5.4 whole divided by 5, which on solving will give you 2.72, right? And you have to find out the value of P minus O, which is 2.72 minus 2.4. That gives you 0.32. So this is answer to the question 0.32, option B. Hope you understood. Next is question number 38. A proper divisor of the integer 2520 is selected at random. Then the probability that it is an odd number is, you are given the number that is 2520. Let's find out the prime factors of it. So this is given by, when you will find out the prime factors, 2 raised to power 3, 3 raised to power 5, 5 raised to power 1 into 7. Now the number of divisors is given by 3 plus 1 multiply 2 plus 1, 1 plus 1, here is 7 raised to power 1. So 1 plus 1, which gives you 4 into 3 into 2 into 2. That is 48. Number of proper divisors. Proper divisors is equal to 48 minus 2. Why? I'm sorry, this 48 minus 2. That is, I'm subtracting 1 and 2520 number itself. This gives you 46. Now, number of odd divisors. So this is 3, 5, and 7. So this gives you 2 plus 1, 1 plus 1, 1 plus 1. That is equal to 3 into 2 into 2, which is equal to 12. Now, number of odd proper divisors. That is equal to 11. Therefore, the required probability is equal to 11 upon 46 from here and here. So that means option A is the correct answer. Hope you understood this. Let's move to the next question then. Question number 39. Each of the two boxes P and Q contain 100 chits numbered from 1 to 100. If one chit is drawn at random from each box, then the probability that the number on the chit drawn from P is square of the number on the chit drawn from Q is. Okay, so you are given two boxes P and Q and both are having 100 chits. Probability of picking one chit which is perfect square from set P is. See how many perfect squares are there? From 1 to 100, it is 10. So the probability of, these are the perfect squares. So probability of picking chits, which is perfect square from P box is 10 upon 100, that is equal to 1 by 10. Now let's move to Q. Probability of picking one chit. Probability of picking up one chit from Q, that is of course 1 by 100. That means the required probability that if you pick up one chit from P, which is a perfect square from Q, is required probability is 1 by 10 into 1 by 100, that is 1 by 1000, that is 0.001. And you have to find out what then the probability that the number is this, that is 0.001, but it's not in the option, but the options are given in percentage. So let's find out the percentage of it. That is 1 upon 1000 into 100, which is 1 by 10 or 0.1%. That is option A is the correct answer. Hope you understood this. Next is question number 40. A problem in algebra is given to students A and B whose chances of solving it are 2 by 5 and 3 by 4 respectively. The probability that the problem is solved if both of them try independently is. Now you are given that the probability of A solving the problem is 2 by 5 and for B the probability is 3 by 4. So probability of neither of them solving, neither of them solves is, see, A doesn't solve, 1 minus 2 by 5 multiply, B doesn't solve. So 1 minus 3 by 4. That is equal to 3 by 5 into 1 by 4 or 3 by 20. So that means the probability, I got the probability that neither of them solves is 3 by 20. That then probability, the problem will be solved is by either of them independently is 1 minus 3 upon 20, which is 17 upon 20. That means we have option A as the correct answer. Hope you got that. Next is question number 41. The probability distribution of a random variable x is given below. So these are the values of x and these are the probabilities. When p of x greater than 3 minus p of x less than 6 is equal to. Okay, so in the question you are given that summation from r is equal to 0 to 7. Probability of event x is equal to x. You know that's equal to 1, right? So for 0, it is 0.01 plus 0.1 plus 0.26, 33.18, 06 plus k plus this is equal to 1, which gives you, on solving it will give you the k's value is equal to 0.02. Now the probability of x is greater than 1, 3. Probability of x is greater than 3. In this case, it is greater than equal to 3. So it is 0.33 plus 0.18, 0.06 plus k plus 0.04. I'll fill the value of k, which is 0.02 plus 0.06 plus 0.02 plus 0.04. Now, adding all of them, you will get 0.63. Next probability x is less than 6 is equal to. So less than 6, we have all these probabilities. 0.01, 0.1, 0.26, 0.33, 0.18, 0.06, that is equal to 0.94. So probability that x is greater than 3 minus probability x is less than 6 is 0.03 minus 0.94, that is minus 0.31. So the answer to the question is option D, minus 0.31. Hope you understood this. Let's move to the next question, number 42. If probability of x is equal to 5r raised to power x, where x is equal to 1, 2, 3, so on, is the probability density function of a discrete random variable x, then r is equal to. See, probability of x is equal to x is given by 5 into r raised to power x, where x is equal to 1, 2, 3, and so on. Right? Now, summation probability x is equal to r is given by 5r upon 1 minus r, that is equal to 1. Question number 42. If probability of x is equal to x is given by 5r raised to power x and x is equal to 1, 2, 3, so on, is the probability density function of discrete random variable x, then r is equal to. See, in this question, you are given probability of the event x is equal to x is given by 5 into r raised to power x. If I take x is equal to 1, this becomes 5r. If I take x is equal to 2, 5r square, x is equal to 3, 5r cube, x is equal to 4, 5r raised to power 4. So that means summation probability x is equal to x is given by 5r plus 5r square, 5r cube, and so on till infinity. So this is a GP, geometric progression series, where the first term is 5r and the common ratio is r. So summation is given by, when it is infinity, so sum is given by a upon 1 minus r. Similarly, over here, the summation will be given by 5r upon 1 minus the common ratio is r, so that is equal to r. And you know the summation of the probability, that's equal to 1, which gives you 5r is equal to 1 minus r, or 6r is equal to 1, or r is equal to 1 by 6. So we have option A as the answer, 1 by 6. Hope you understood. Then let's move to the next question. Question number 43. If a point Pxy moves such that the sum of square of its coordinates is equal to their product, then the locus P excluding origin is. Okay. So as per the question, the coordinates sum of square of the coordinates, so x square plus y square is equal to their product. So x square plus y square is equal to xy. Let's divide both the sides by xy. Both sides by xy. So you have x upon x square upon xy. Let's write like this. Y square upon xy is equal to 1, or this will give you x upon y plus y upon x is equal to 1, which is option C. So pretty easy question. Next is question number 44. When the origin is shifted to minus 1, comma 2 by the translation of x's, the transformed equation this is. The transformed equation of this is. Okay, so you have said that when the origin is shifted to this point, so what will the coordinates after translation? X will change to, after translation, x becomes x minus 1 and y becomes y plus 2, right? So this equation, which is x square plus y square plus 2x minus 4y plus 1 is equal to 0. This is the original equation. Now this will become x minus 1. Sorry, this is, see, x will be x plus 1. So x plus 1 square plus y minus 2 whole square plus 2 into x minus 1. Question number 44. When the origin is shifted to minus 1 comma 2 by the translation of x's, the transformed equation of this is. See, when the origin is shifted to this point, so x and y will change accordingly. X will become now x minus 1 square plus y plus 2 square plus 2 into x minus 1 minus 4 into y plus 2 plus 1 is equal to 0. Let's open it up. You will have x square plus 1 minus 2x plus y square plus 4 plus 4y plus 2x minus 2 minus 4y minus 8 plus 1 is equal to 0. 2x will cancel, 4y will cancel, and you have x square plus y square plus 6 minus 8 minus 10 is equal to 0, which gives you x square plus y square is equal to 4. So this x and y are not the same as these ones, but these are the new coordinates of the new equation after the translation. So this will be denoted by capital X and capital Y whole square is equal to 4. Right. So that means we have option A as the answer. Hope you got that. Next is question number 45. If the portion of the straight line intercepted by the coordinate x's is divided by this point in the ratio 2:3, then the product of the intercepts made by this line on the axis is. Okay, so you are given a coordinate axis. Sorry for this. Let's make it again. Okay, so this is the line. Of course, the coordinates are, let it be 0, b, and these coordinates, let it be 0, a. So now this is intercepted by a line. Here the point of intersection is 2, 3, and it is intersecting in the ratio 2:3. Let's draw it over here. So here is 0b, a0. There is a point 2, 3, which is intersecting the line in the ratio 2:3. So according to applying the section formula, you have 2. This 2 is equal to 2 into a plus 3 into 0 upon 2 plus 3, which gives you 5 into 2, 10 is equal to 2a, or a is equal to question number 45. If the portion of the straight line intercepted by the coordinate axis is divided by the point 2, 3 in the ratio 2:3. So you are given this, there is a line and these are the coordinates a, 0 and 0, b for the y-axis and for the x-axis respectively. Now, there's a point 2, 3. This point is dividing the line in the ratio 2:3. So here is 2 and here is 3. Let's draw it over here. This is the point a, 0. Zero, b. This is the point 2, 3. Now this line is being divided in the ratio 2:3. By applying the section formula, you have 2 is equal to 0 plus 3a upon 2 plus 3, which gives you 3a is equal to 10. Also, 3 is equal to 2b plus 3 into 0, which is equal to 0 upon 2 plus 3. That gives you 2b is equal to 15. We have to find out the product of the intercepts made by the line on the x-axis. So intercepts are a and b. That means you have to find out a product b or ab. A is equal to 10 upon 3 and b is equal to 15 upon 2. This gives you 25. So you have option A as the answer. Hope you got that. Let's move to the next question. Question number 46. If the slope of the line L is 2, M1 and M2 are the slope of the two lines which are inclined at an angle of pi by 6 with L, then M1 plus M2 is equal to. Okay, first thing you're given that there are two lines and angle between them, that is theta. Between lines, that is theta, is given to you as pi by 6, and the slopes of the lines are M1 and M2. Okay, it's given over here. That means tangent of theta, you know the formula, that's given by M1 minus M2 upon 1 plus M1 into M2. Tangent of pi by 6 is equal to M1 minus 2. Now, why this 2? It's given slope of a line L is 2, and if M1, M2 are the two lines which are inclined at an angle of pi by 6 with L, so that means one of the lines will have the slope same as that of L. That is, I'm taking M2 is equal to one of the lines I'm taking this as 2. So this is equal to 1 plus 2. Question number 46. The slope of the line L is 2. M1 and M2 are the slope of two such lines which are inclined at an angle of pi by 6 with L. Then M1 plus M2 is equal to. Okay, you are given that there are two lines which are inclined at an angle of pi by 6 with L. Definitely, these are two different slopes, right? So generally, slope of any line which is inclined at an angle of pi by 6 with L will be given by, say, theta is the angle between a line and L. So slope of this line will be equal to, let's find out. You know, tangent of theta is equal to M1 minus M2 upon 1 plus M1 into M2. One of the line is L, the slope 2. Tangent of pi by 6 is equal to, that's M minus 2 upon 1 plus 2M modulus, right? Tangent of pi by 6, this is 1 by root 3 is equal to M minus 2 upon 1 plus 2M. Let's do the cross multiplication. You have 1 plus 2M mod is equal to root 3 into mod of M minus 2. Now it can have two values. Either 2M plus 1 will have this value, or 2M2, that's the second line with the slope M2, plus 1 will have this value. Here is M1. Okay, so in either of the case, let's solve further. You will have, I'll concatenate the M1 terms. So you will have 2 minus root 3 into M1 is equal to minus 2 root 3 minus 1, or M1 will be equal to minus 2 root 3 minus 1 upon 2 minus root 3. And over here in the second one, you will have 2 plus root 3. M2 is equal to 2 root 3 minus 1, or M2 is equal to 2 root 3 minus 1 upon 2 plus root 3. Now I have M1 and M2 values. You have to find out what is sum of the two. So this is minus 2 root 3 minus 1 upon 2 minus root 3 plus 2 root 3 minus 1, 2 plus root 3. Now this is equal to 2 minus root 3, 2 plus root 3, which is minus 2 root 3 minus 1 multiplied by 2 plus root 3 plus 2 root 3 minus 1, 2 minus root 3. That is equal to, let's solve further. You have minus 4 root 3 minus 2 minus 6 minus root 3 plus 4 root 3 minus 2 minus 6 plus root 3 whole divided by a plus b into a minus b is a square minus b square. So this will cancel out, and then further this will also cancel, and you will have minus 16 upon 1, that is equal to minus 16. So you have option D as the answer. Hope you got that. Let's move to the next question, number 47. In a triangle ABC, 2x plus 3y plus 1 is equal to 0 and x plus 2y minus 12 is equal to 0 are perpendicular bisectors of AB and AC respectively. Let's draw the figure to understand this. So given this triangle ABC, this is A, it's having the coordinates as 3, 2. This is B and C. Okay, now it's given this is the perpendicular bisector of AB. Let's draw the perpendicular bisector of AB. This is the perpendicular bisector, and also draw the perpendicular bisector of AC. Let's say this meets AB at D and AC at E. This is the point of their intersection, and equation of this line is given by 2x plus 3y plus 1 is equal to 0, and this line is x plus 2y minus 12 is equal to 0. Correct? Okay, we have written everything. We have to find out the slope of BC. If I get the coordinates of B and C, then I'll find out the slope of BC very easily. Let's go. Okay, now first of all, you are given the equation of this line, and this is AB. First of all, 2x plus 3y. I'm taking two lines. I'll write them simultaneously. So the first line is 2x plus 3y plus 1 is equal to 0. And the second one is x plus 2y minus 12 is equal to 0. Over here, what is the slope? It is given by minus 2x minus 1 upon 3 upon 3. So slope in this case is minus 2 by 3. And in this case, slope is minus 1 by 2x plus 12. So slope in this case is equal to minus 1 by 2. Now it's given that AB is perpendicular to this line. So slope of AB will be equal to 3 by 2. I hope you know this. The product of slopes, I'll write it over here. Product of slopes of perpendicular lines is equal to minus 1. Okay, so that means if this is minus 2 by 3, the slope of AB will be 3 by 2. Similarly, the slope of AC will be equal to 2. We got the two slopes. We have the point A. Let's frame the equations. So, equation of AB. Let's frame that. That's given by A was 2, 3, and I get the slope. So, this is y minus 3. Sorry, it's 3, 2. So it is given by y minus 2 is equal to 3 by 2 x minus 3, which gives you the equation as 3x minus 2y minus 5 is equal to 0. This is for AP. Now, equation of AC. This is given by y minus 2 is equal to 2x minus 3. This gives the equation as 2x minus y minus 4 is equal to 0. Right, I got the two equations. I got the equation for AB and AC. Now let's find out the coordinates of D and E. I'll draw the line. Now, D coordinates, let's find out. And here I will find out E coordinates. It's given that this line is the perpendicular. This line is the perpendicular bisector of AB. That means D point bisects AB. Therefore, D's coordinates will be, what will be the D's coordinates? To find out D's coordinates, I don't know the D's coordinates, so I have to find some alternative. I have the equation of this line AB. I have, okay, I'll solve it here. AB equation was 3x minus 2y minus 5 is equal to 0. And the second one was 2x plus 3y plus 1 is equal to 0. So I'm using these two equations, the equation of these two lines, to find out the coordinates of D. So let's solve them simultaneously. Let's multiply this one with 2 and this one with 3. You will get 6x minus 4y is equal to 10 and 6x plus 9y is equal to minus 3. Minus minus plus, you will have, they will cancel out, and you will have the coordinates minus 13y is equal to 13, which will give you y is equal to minus 1, and you will get the value of x is equal to 1 on solving. Okay, now these were for the D coordinates. Let's find out the E coordinates. For E coordinates, now the second equation was, the equation of AC was 2x minus y minus 4 is equal to 0. 2x minus y minus 4 is equal to 0. And the equation of AC was this. And what was the equation of this line? It was x plus 2y minus 12 is equal to 0. X, it was x plus 2y minus 12. X plus 2y minus 12 is equal to 0. So let's multiply this equation with 2. Now these two equations will become 2x minus y minus 4 is equal to 0, and 2x plus 4y minus 24 is equal to 0. Minus minus plus, they will cancel. Minus 5y is equal to minus 20, or y will be equal to 4, sorry. Okay, if y is equal to 4, you will solve, you will get the x also 4. So the coordinates of D came out to be 1 comma minus 1, and the coordinates of E came out to be 4 comma 4. I already had the A coordinates as 3 comma 2, it's given, and A is 3 comma 2. Let's find out the, now D is midpoint on AB, which gives D 1 comma minus 1 is equal to, if I'm taking the coordinates of B as AB and C as CD, so this will be equal to A plus 3 upon 2, B plus 2 upon 2, which gives you A plus 3 upon 2 is equal to 1, and B plus 2 upon 2 is equal to minus 1. That is, A's value will be equal to 2 minus 3, that is equal to minus 1, and B will be equal to minus 4. Okay, so that means the B point has the coordinates as minus 1, minus 4. Hope you got that. Now, similarly, E is midpoint on AC, right? So that means 4 comma 4 is equal to 3 plus C upon 2 and 2 plus D upon 2, which makes 3 plus C upon 2 is equal to 4, which makes C is equal to 5, and 2 plus D upon 2 is equal to 4, which makes D is equal to 6. So the coordinates over here for the C point came out to be 5 comma 6. You have to find out slope of BC, that is given by y2 minus y1. So 6 minus of 4 will be 6 plus 4, y plus 1, that is going to give you 10 by 6, which is 5 by 3. So the slope of the line is 5 by 3, that is option C. Hope you understood this. Next is question number 48. If the equation of the line having the slope m, where m belongs to integers passing through 1 comma 1, making an angle of tan inverse 5 by 7, with the line x plus y minus 3 is equal to 0 is this, then what is the value of AC? Okay, you are given that L passes, this line L passes through 1, 1 and makes an angle of tan inverse 5/7 with this line. Correct. You know tangent of theta, then it is equal to, it's given by m plus 1 upon 1 minus m. Now, how is that here? Y is equal to minus x plus 3. So, slope over here is equal to minus 1. So, minus of minus 1 will be plus 1 and this will be 1 minus m. Now, tangent of the theta angle between them was tan inverse 5/7. That is equal to m plus 1 upon 1 minus m modulus, which gives you 5/7 is equal to m plus 1 upon 1 minus m, or 5 minus 5m is equal to 7m plus 7, which gives minus 12m is equal to 2, or m is equal to minus 1/6. Now it can have two values. Now this one was for the positive. Also, let's consider the negative ones. 5/7 can be equal to question number 48. If the equation of the line having the slope m, where m belong to integers, passes through the point 1, 1, making an angle of tan inverse 5/7 with the line x plus y minus 3 is equal to 0, is this, then what is the value of AC? So you are given this, that the line L passes through 1, 1 and makes an angle of tan inverse 5/7 with the line x plus y minus 3 is equal to 0. That means if I'm taking these two lines, the tangent, the theta between, theta is the angle between these two lines. Tangent of theta is given by, you know the formula, m1 minus m2 upon m1 plus m1 into m2. From this line, the slope is equal to minus 1. Right? The coefficient of x, slope is equal to minus 1. So that means tan of the angle between them was 5, tan inverse 5/7, that is equal to m. Minus of minus 1 will be plus 1, 1 minus m. So this is 5/7 is equal to m plus 1 upon 1 minus m. This gives you 7m plus 7 is equal to 5, 1 minus m. Now it can have two values. 7m plus 7 can be equal to 5, 1 minus m, or 7m plus 7 can be equal to 5m minus 1. Solving this, you will have plus 5m is equal to minus 2, or 12m is equal to minus 2, which will give you m is equal to minus 1/6. This is not possible because it is said in the question that m belongs to integers. So this is not possible. Let's move to the second option. 7m plus 7 is equal to 5m minus 1, which gives you 2m is equal to minus 8. Wait, 7m plus 7 is equal to 5m. Sorry, here is got to be 5. So this gives you minus 12, or m is equal to minus 6. So m is equal to minus 6 definitely can be considered. And I have the point as through which the line is passing 1 by 1. Slope of the line came out to be minus 6. Let's frame the equation. Y minus 1 is equal to minus 6 into x minus 1. So this is y minus 1 is equal to minus 6 plus x, or 6x plus y. 6x plus y minus 7 is equal to 0. This is the line. Now, on comparing this with the given equation, ax plus by plus c is equal to 0. You have a as 6, b as 1, and Yeah. And C as -7. A is equal to 6, B is 1, and C is -7. So AC, that is 6 into -7, is -42. Option B. So option B is the correct answer. Hope you understood. Next is question number 49. From the point 3, comma -4, the perpendicular lines L1 and L2 are drawn on each of the lines S is equal to this. Then the area of the quadrilateral formed by the pair of the lines S is equal to 0, L1 and L2 is in square units is. Okay, so you are given S as 2x square plus 3xy minus 2y square minus 7x plus y plus 3 is equal to 0. Let's make the factors of it. Question number 49. From the point 3, comma -4, perpendicular lines L1 and L2 are drawn on each of the lines. S is equal to all of this. The area of the quadrilateral formed by the pair of lines S is equal to 0, L1 and L2 is in square units is. Okay, so here you are given S equation as 2x square plus 3xy minus 2y square minus 7x plus y plus 3 is equal to 0. So using the methods, we will factorize and the two factors will come out to be x plus 2y minus 3x, 2x minus y minus 1. Now equation of line L1, equation of line L1 drawn from this point 3, comma -4 on x plus 2y minus 3. So this is the first equation of the first line and second line. So this is given by, first of all, I'll find out the slope of this line. What is slope over here? It will be y is equal to -1 by 2x plus 3 by 2. So slope is -1 by 2. Since L1 is perpendicular to this line, so slope of L1 will be equal to 2 because the product of the two slopes is equal to -1. Now let's frame the equation for the line L1 from 3, comma -4 on x plus 2y minus 3 is equal to 0. That is L1 is given by y plus 4 is equal to 2 into x minus 3, which will give you L1's equation as 2x minus y minus 10 is equal to 0. Similarly, equation of line L2 from 3, comma -4 on the line 2x minus y minus 1. Now, what is the slope of this line? It is equal to 2. So, slope of L2, because this line and L2, they are perpendicular to each other, the slope of L2 will be equal to -1 by 2. Now, let's frame the equation for L2. L2 will be given by y plus 4 is equal to -1 by 2x minus 3, which will be, solving, you will get the value of equation of L2 as x plus 2y plus 5 is equal to 0. Okay, now we have all the 4 equations of the lines. Let's proceed further. Parallel distance between line x plus 2y plus 5 is equal to 0 and x plus 2y minus 3 is equal to 0. The parallel distance between them is given by modulus of 5 plus 3 divided by root of 1 square plus 2 square, which is equal to 8 upon root of 5. Next, parallel distance between 2x minus y minus 1 is equal to 0 and 2x minus y minus 10 is equal to 0. It is given by 10 minus 1 upon root of 2 square plus -1 square, which is equal to 9 upon root of 5. Okay, now you have to find out the area of the quadrilateral. So the required area is equal to 8 by root 5 multiplied by 9 by root 5, which is equal to 72 upon 5 square units. So the 72 upon 5 is the correct answer, option B. Hope you got that. Next is question number 50. The line x upon 3 plus y upon 2 is equal to 1, and a pair of lines both passing through the origin forms an isosceles triangle. Okay, so let's frame this is the coordinate axis, and this is the line x upon 3 plus y upon 2 is equal to 1. See, when I put x is equal to y is equal to 0, x value will be equal to 3. And when I put x is equal to 0, y will have the value as 2. So these are the 2 points where the line x upon 3 plus y upon 2 is equal to 1 meet the coordinate axis. Okay, now, and a pair of line both passing through the origin forms an isosceles triangle. So this is suppose these are the 2 lines. Okay, it's not correct, but geometric construction wise this is not correct, but the angle between the 2 lines is 90-degree, because this pair of lines, it's perpendicular, it is set. Let this be the angle theta. Let's name this as point P, and this as point Q. This is origin O. Okay, so now P's coordinates will be given by O plus 0 plus R cos theta, 0 plus R sin theta, and Q will be given the coordinates as 0 plus R cos 90 plus theta, 0 plus R sin 90 plus theta, which will give you the coordinates of Q as minus R sin theta and R cos theta. See, cos 90 plus theta in the second quadrant, it is negative. So you will have minus R sin theta, and sign will be changed to cos. And this quadrant, second quadrant, it's positive. So it will be R sin cos theta. Next, if you see OP will be given by y is equal to x tangent of theta, and OQ will be given by y is equal to minus x cotangent of theta. Okay, now let's say from here, Px and y is equal to Q minus x comma y. Also, let's move to this line. X upon 3 plus y upon 2 is equal to 1, which gives you 2x plus 3y is equal to 6, which gives you R 2 cos theta plus 3 sin theta is equal to 6. Also, R into minus 2 cos theta plus 3 sin theta is equal to 6, because both of these lines, they cut this line. So therefore, from 1 and 2, you have 2 cos theta plus 3 sin theta is equal to minus 2 cos theta plus 3 sin theta. Sorry, this is some mistake. I'll rewrite these lines. That was R 2 cos theta plus 3 sin theta is equal to 6, and R minus 2 sin theta plus 3 cos theta is equal to 6 from here. Okay. So now that means from 1 and 2, you have 2 cos theta plus 3 sin theta is equal to minus 2 sin theta plus 3 cos theta, which gives you 5 sin theta is equal to cos theta, or tangent of theta is equal to 1 by 5. That means, see, y was equal to x tangent of theta. So that means y is equal to x upon, this was there. So this is equal to y is equal to x upon 5, or 5y minus x is equal to 0. Now, second thing, and 5x plus y is equal to 0. So let's multiply them. 5x plus y into 5y minus x. This is equal to 0. This will give you 25xy minus 5x square plus 5y square minus xy is equal to 0. So that makes, I'll take 5 common, x square minus x square plus y square plus 24 xy is equal to 0. So multiplying both sides by minus 1, you have 5x square minus y square minus 24 xy is equal to 0. This is the required equation. Okay, so we have option B as the answer. Hope you got that. Next is question number 51. It says if 2 comma alpha does not lie outside this circle and this, then alpha lies in which of these intervals? So first thing, I'll pick up this equation, x square plus y square minus 13 is equal to 0. So if this point does not lie outside the circle, that means this point surely lies inside the circle, which means if I put x is equal to 2 and y is equal to alpha, so this will give you 2 square, that is 4, plus alpha square minus 13 is definitely not greater than 0 because this point is lying inside the circle and not outside. Okay, that means alpha square is not greater than 9 or alpha square is obviously less than equal to 9, which gives you the value of alpha as it lies between minus 3 and 3. Second one, I'll pick up this equation now. Let's put the same thing. So 4 square plus alpha square plus 2 minus 2 alpha minus 14. This is because this point is lying inside the circle. So this is not greater than 0. This will give you alpha square minus 2 alpha minus 8 is less than equal to 0. That gives alpha minus 1 whole square is less than equal to 9, or minus 3 alpha minus 1 lies between minus 3 to 3, which gives you minus 2 is less than alpha is less than equal to minus 4. So from both of these equations 1 and 2, from 1 and 2, we get that alpha belongs to minus 2, 3. That is option D. Hope you understood this. Let's move to the next question then. Question number 52. The locus of the center of the circles passing through the origin and cutting off a chord of length 2 units of line x is equal to 1 is. Let's draw the diagram to understand the problem. Here is the coordinate axis. Now this is the circle which is passing through the origin. Okay. And this is the line x is equal to 1. It is said that it's cutting off a chord of length 2 units of the line x is equal to 1. So if this is the center and this is the perpendicular from the center, let this point be N, this be C. So Cn, this point N is cutting off this chord. If this, I name this as P and this one as Q. So N, Q and NP, that is equal to 1 is to 1 because the chord is of length 2 units. That means PQ is equal to 2 units, which means N divides PQ by 6 PQ, you can say. N by 6 PQ, which makes NP is equal to 1 and PN is equal to 1. Now, since the equation of the, since the circle is passing through the origin, this is origin. Therefore, the equation of the circle is given by x squared plus y squared plus 2gx 2fy is equal to 0. Here the center is given by minus half the coefficient of x minus half the coefficient of y. So the center is given by minus g comma minus f. Also radius is g square plus f square and c is not there. C is 0. So minus 0. This is the radius, or radius square is equal to g square plus f square. Okay, now we have to find out the locus of the center of the circles for this. Correct? Now, if I take the triangle CPN, correct? What is the length of CN? It is given by the mode of -1 minus G. Cx is equal to -1, and from here, this is the x coordinate is minus G. So the length of Cn is given by -1 minus G, or that's equal to simply G plus 1. And the CP, that's equal to radius of that circle. And we just calculated the radius is equal to root of G square plus X square. Correct? And NP is equal to 1. We know this. We already discussed it over here that N bisects PQ. Therefore, NP is equal to 1. Now, if I consider triangle CPN, then, by using the Pythagoras theorem, CP square is equal to CN square plus NP square or PN square. And the CP, that is equal to CP is radius. CP square is G square plus F square. Cn is G plus 1 square, and NP is 1 square. That gives you G square plus F square is equal to G square plus 1 plus 2G plus 1. Or you have F square is equal to 2, 1 plus G. Okay. I'll write it like this. F square is equal to 2G plus 1, which is the equation of parabola. That means we have option C as the answer. Hope you understood this. Let's move to the next question, number 53. The number of common tangents that can be drawn to this and this circle is. So you have to find out, first of all, see, the number of tangents depends upon C1, C2, that is the distance between the two centers, and the sum or the difference between the two radii. I'll discuss it. First circle is x square plus y square is equal to 1, and the second one is x square plus y square minus 2x minus 6y plus 6 is equal to 0. Here the center of the circle is 0, 0, because x and y coefficients are missing, and radius is root of 0 square plus 0 square minus of -1, that is equal to 1. In this case, center, the center is given by minus half the coefficient of x minus half the coefficient of y. So here the center is given on the second case, it's minus half the coefficient of x is 1 minus half the coefficient of y is 3. So the center is 1 and 1 comma 3, and radius is root of 1 square plus 3 square minus of 6. So that's equal to 10 minus 6, or root of 4, or that is equal to 2. So the radius in the second case, this one, if I'm taking as radius 2, radius 1, center 1, and center 2. Now, C1, C2, that is a distance between 0, 0 and 1 comma 3 is root of 1 minus 0 plus 3 minus 0, which is equal to root 10. I'll leave it like root 10 only. The value of root 10 is approximately between 3 and 4. This is approximately 3.12. R1 plus R2. What is that? 3. Clearly, C1, C2 is greater than R1 plus R2. That means there are 4 tangents. Therefore, there will be there will be 4 common tangents. So how is that? See, if this is the 2 cases when the circle have the same radii, but in this case the radii are different, right? So this is circle 1 and circle 2. So the 2 possible common, 4 possible common tangents are, this is 1 and 2 from an external point, also 3 and 4. So 1, 2, 3, and 4. These are the 4 possible common tangents over here. And you have option A as the correct answer. Hope you got that. Next is question number 54. The equation of the circle passing through the points of intersection of the two circles, this, and the point this is. So equation of the circle which is passing through the point of intersection of these two circles. This equation will be given by S1 plus some lambda S2 is equal to 0, which is x square plus y square plus 2x plus 3y plus 1 plus lambda x square plus y square 4x 3y plus 2 is equal to 0. Okay, now it also passes through, this circle passes through minus 1 minus 1. This circle passes through minus 1 comma 1. Therefore, let's fill in this equation. You have 1 square plus minus 1 square plus 1 square plus 2 into minus 1, 3 into 1 plus 1 plus lambda minus 1 square 1 plus 1 plus minus 4 plus 3 plus 2 is equal to 0. That's equal to 2 minus 2. This will cancel. 4 plus lambda into 1, 2, 3, 4. And this will cancel. This is equal to 0, which will give you lambda is equal to minus 4 by 3. Now let's frame that equation. You have it as x square plus y square plus 2x plus 3y plus 1 minus 4 by 3 x square plus y square plus 4x plus 3y plus 2 is equal to 0. This will give you, I'll take x square common, 1 minus 4 by 3 plus y square 1 minus 4 by 3 plus x 2 minus 16 by 3 plus y 3 minus 12 by 3 plus 1 minus 8 by 3 is equal to 0. So you have it as minus 1 minus x square by 3 minus y square by 3, and this is 6 minus 10x by 3. Similarly, here is 9. So actually this is gonna be 4. So that is equal to minus y, and 1 minus this is minus 5 by 3 is equal to 0. Let's cross multiply both sides by minus 3x. You will have x square plus y square plus 10x plus 3y plus 5 is equal to 0. So this is answer to the question, and option A is the correct answer. Hope you understood this. See, I have used this equation to fill the value of lambda. Okay, hope you understood this. Next is question number 55. If the circle x squared plus y squared plus 2kx plus 4y minus 4 is equal to 0 has its center in the fourth quadrant and touches this circle, then the value of k is. Okay, you have this circle here. The center is minus half the coefficient of x minus half the coefficient of y. So minus k minus 2. This is center of this circle. Now, this circle lies in the fourth quadrant. If this lies in the fourth quadrant, then that means x coordinate in the fourth quadrant. X is positive, y is negative. Correct. That means minus k is greater than 0, which means k is less than 0. Right? So the center, also if I'm taking this equation now, center of circle x square plus y square plus 6x minus 2y plus 6 is equal to 0. Here the center is minus half the coefficient of x minus half the coefficient of y. So minus 3 comma 1, and the radius is minus 3 square, that is 9, minus plus 1 square, that is 1, minus of c, which is 6, that is equal to root of 4, and that is equal to 2. Okay, fine. So now it is given and touches this circle. So both the circles, they are touching it, since both circles are touching. That means touching each other. There means C1, C2 is equal to R1 plus R2. And what was R1 over here? Okay, we didn't calculate. The radius in this case was root of k square plus minus 2 square, that is this 4, and minus of minus 4, that is equal to plus 4, that is k square plus 8 root, that is the radius. So C1, C1 had the coordinates as minus k minus 2, and C2 had the coordinates as minus 3 comma minus 1. So C1, C2 is given by root of minus k plus 3 square plus minus 2 minus 1 square, which is equal to k square plus 9 minus 6k, and minus 3 square is 9. So that is equal to root of k square minus 6k plus 18. So C1, C2 is equal to root of k square minus 6k plus 18, and R1 plus R2 is 2 plus this root of k square plus 8. Okay. Yeah. All right. So now you try different options A, B, C, and D. You will find that k is equal to minus 1 satisfies this given equation. Let's fill it. So root of minus 1 square minus 6 minus 1 plus 18 should be equal to 2 plus root of minus 1 square plus 8. This gives you 1 plus 6 plus 18 should be equal to 2 plus root of 9. That's equal to root of 25 should be equal to 5, which is true. So we have option D as the answer. Hope you understood this. Next is question number 56. If the parabola having the horizontal axis and passing through these points, then the y coordinate of the focus of that parabola is, okay, first thing, equation of the parabola, general equation is y square plus ay plus bx plus c is equal to 0. Now, since this passes through these 3 points, minus 2 comma 1, 1 comma 2, minus 1 comma 3, then this equation at minus 1, minus 2 comma 1 becomes 1 plus a minus 2b plus c is equal to 0. At the point 1 comma 2, this equation becomes 4 plus 2a plus b plus c is equal to 0. And the third point, minus 1 comma 3, this equation becomes 9 plus 3a minus b plus c is equal to 0. So let's write down these 3 equations properly now. So you have 3 plus ab plus 3b is equal to 0. The second one, 5a plus 5 plus a plus 5 plus a minus 2b is equal to 0. Or the third one, it's 2 minus 5b is equal to 0. See, how did I get to these equations? Let's discuss that first. Okay. Question number 56. If a parabola having the horizontal axis and passing through these 3 points, then the y coordinate of that parabola, phi coordinate of the focus of that parabola is. So in this case, general equation of parabola is y square plus ay plus bx plus c is equal to 0. Now there are 3 points which are passing. The parabola is passing through these 3 points. So at the first point, minus 2 comma 1, this equation becomes y squared, which is equal to 1 plus a minus 2b plus c is equal to 0. At the second point, 1 comma 2, this equation becomes 4 plus 2a plus b plus c is equal to 0. At the third point, minus 1 comma 3, this equation becomes 9 plus 3a minus b plus c is equal to 0. Now let's subtract these two equations. You will have 3 plus a, 3 plus a plus 3b is equal to 0. Now let's subtract these two equations. Then you will have 5 plus a minus 2b is equal to 0. Now let's let's subtract these two, minus minus and plus over here, then minus. So you will have a minus 2 plus 5b is equal to 0, which gives me b is equal to 2 by 5. Okay, so if b is equal to 2 by 5, let's find out. You will find out that the value a of a comes out to be from here, or any equation you can calculate. A will come out to be minus 21 by 5 and c will come out to be 4. So these are the 3 values. You have the 3 equations. You can find out 3 variables. So equation becomes y square minus 21 by 5y plus 2x by 5 plus 4 is equal to 0. So this can be written as y minus 21 by 10 whole square plus 2 by 5 x plus 4 is equal to 0. So y coordinate of focus will be same as y coordinate of vertex. That is 21 by 10. So the answer to the question is 21 by 10, and we have option B as the correct answer. Hope you got that. Next is question number 57. If a square plus 2hxy minus plus b square minus 82x plus 98y plus 144 is equal to 0 is the equation of the parabola with this focus and directrix 3x minus 2y plus 5 is equal to 0, then this represents what? So you are given that the focus is this. It's right. Focus is given by 2 comma minus 3 and directrix is 3x minus 2y plus 5 is equal to 0. So let's frame the equation according to that. X minus 2 whole square, y plus 3 square is equal to 3x minus 2y plus 5 square divided by 3 square plus 2 square. Okay, let's open it. You have here, this is 9 plus 4, that is equal to 13. So let's cross multiply 13. X square plus 4 minus 4x, y square plus 9 plus 6y is equal to this. Three x squared minus 2y plus 5. Let's open this. 9x square, a square plus b square, that is 4y square plus c square. Then you have plus 2ab, which is minus 6xy minus 10y plus 15x. This is 13x square minus 52x plus 52 plus 13y square plus 78y plus 117 is equal to 9x square plus 4y square plus 25 minus 12xy minus 20y plus 30x. That is 4x square plus 12xy plus 9y square minus 82x plus 98y plus 144 is equal to 0, or 4x square plus 12xy plus 9y square is equal to 0, right? See, over here, if I look at this one, let's compare this equation with the given equation. So this is actually equivalent to ax square plus 2hxy plus by square minus 82x plus 98y plus 144 is equal to 0. So I'm comparing this with this equation. So this represents here ax square plus 2hxy plus by square is actually this. Okay. So this is 2x plus 3y whole square. This is not equal to 0. Okay. So ax square plus 2hxy plus by square is actually this, which can be represented by 2x plus 3y whole square. That means these are two coincident lines. Correct? See, by solving this equation, by solving this whole equation, we got to over this equation. Now, this is equivalent to this given equation. Correct? That means ax square plus 2hxy plus by square is actually equal to 4x square plus 12xy plus 9y square, which is the perfect square of 2x plus 3y. That means these are two coincident lines, 2x plus 3y, and the second line also 2x plus 3y. That's it. These are the two coincident lines, which makes option D to be the correct answer. Hope you got that. Next is question number 58. Question number 58. Students, before moving to this question, here's a quick reminder to visit our website www.examsnet.com. There you will find a variety of entrance exam question papers along with this one. Their PDF solutions are also available there. You can also download our app. The link is available in the description box. So let's start with question number 58. It says an ellipse has its major axis along the y-axis, minor axis along the x-axis. If the length of latest rectum is 2/3 times of the minor axis, then the eccentricity you have to find out. Okay, let's write down. First of all, see, this is saying major axis is along y-axis and minor is along x-axis. So see, this is somewhat the ellipse looks like. So this is a comma 0 over here, and this is a comma 0. This is minus a comma 0. This one is 0 comma b, and this one is 0 comma minus b. This is x and the y-axis. So the latest rectum is 2/3 the length of minor axis, which means latest rectum is given by 2a square upon b, that is equal to 2/3 the length of minor axis, that is equal to 2a, which gives a upon b is equal to 2/3, or a is equal to 2b upon 3. You know one thing, formula for a square is equal to b square into 1 minus a square. Let's fill in this equation. You have 4b square upon 9 is equal to b square. 1 minus e square, you have 4 upon 9 is equal to 1 minus e square, or e square is equal to 5/9. That gives you e is equal to root of 5 upon 3. So that means you have option C as the answer. Hope you got that. Then let's move to the next question, number 59. If the length and breadth of a rectangle of maximum area that can be inscribed in an ellipse of x square upon a square plus y square upon b square plus is equal to 1 are this and this respectively, then again you have to find out the eccentricity in this case. See, the length of the rectangle is given to you as 8 root 2. That means a root 2 is equal to 8 root 2, which gives you a's value as 8. And now you are also given that the breadth is equal to 4 root 2, which means b root 2 is equal to 4 root 2. That gives you b's value as 4. Now centricity formula. See, the eccentricity is given by root of a square minus b square upon a square. So this is equal to 8 square minus 4 square upon 8 square. That is 64 minus 16 upon 64, or this is equal to 48 upon 64. That is equal to root 3 by 4. So eccentricity is equal to root 3 by 2. That's it. We have option B as the answer. Easy question. Next is question number 60. If x squared upon 8 alpha plus 3 plus y squared upon 2 minus alpha is equal to 1 represents a hyperbola, then alpha lies in. See, over here, first thing, alpha plus 3 is got to be greater than 0 and 2 minus alpha is less than 0, right? Since this represents a hyperbola, so that means if I multiply the two, alpha plus 3 is greater than 0, or you can say alpha minus 2 is also greater than 0. Let's multiply the two. Alpha plus 3 into alpha minus 2 is greater than 0, which means alpha belongs to minus infinity minus 3 union 2 to infinity. That's it. You have option D as the answer. Hope you understood this as well. Next is question number 61. 4 points A, B, C, D forms a square, parallelogram, rectangle, or rhombus. See the different properties of it. First of all, I have to see the length of all the 4 sides and then check out further. First, let's find out the length of AB, that is given by root of 4 minus 2 square plus minus 2 plus 1 square, 3 minus 1 square, which is equal to, that's equal to 4 plus 1 plus 4, which is equal to, give me a minute, this is equal to 4 and this is equal to 1 and that's equal to 4. That's equal to 9 or 3. Yeah. So AB is equal to 3. Let's find out for BC. This is equal to root of 2 minus 2. That is BC. 4 minus 4. That's equal to 0 plus 5 plus 2. That is 7 square. That is equal to 49. Minus 7 minus 1. That's minus 8. So this is 64. This gives you root of 113. That's 60. That's BC. Let's go to find CD now. CD is given by 2 minus 4. That's 2 square, which is 4 plus 1 plus 4, which gives you 3. Next, AD is given by root of 2 minus 2, 0. 6 plus 7, 1, 7. That's 49. And minus 5 minus 3, that is 64. So that is again equal to root of 130. So you see one thing, AB is equal to, CD is equal to 3 and BC is equal to AD, that's equal to 113. So that means opposite sides are equal, right? That means either it can be a rectangle, so square is not there, and a rhombus is not there because all the sides are equal. That means either it can be a rectangle or a parallelogram. So let's check the properties of the diagonals in this case now. So the diagonals will be AC, AC will be given by root of 4 plus 36 plus 100, which is equal to root of 140. Similarly, BD will be given by root of 4 plus 64 plus 36, that is 104. Since the two diagonals, they are not equal. Diagonals are not equal. That means it's not a rectangle as well. So the only possibility is it is a parallelogram. So the given points form a parallelogram, which makes option B as the correct answer. Hope you got that. Next is question number 62. Suppose L1 and L2 are two lines having the direction ratios this and this respectively. The direction cosines of a line perpendicular to L1 and L2 are L and N. Then mod of L plus mod of M plus mod of N is equal to. See the two, these are two lines. If the direction cosines of a perpendicular line which is perpendicular to both L1 and L2 is LMN. So let's find out the perpendicular line direction cosines. This is I, J and K. Then you have 1 minus 2 minus 2, 0 to 1. That is equal to I cap minus 2 plus 4 minus J. So this is 1 minus 0 plus K 2 minus 0, which makes it 2I minus J plus 2K. So here the unit vector will be given by. So first of all, let's find the modulus of this 2I minus J and the K vector. The modulus will be given by, magnitude will be given by 2 square 4 plus minus 1 square 1 plus 4, that is equal to 3. So the unit vector in this case will be 2 upon 3I minus 1 upon 3J plus 2 upon 3K. Therefore, L is equal to 2 by 3. M is minus 1 by 3. 1 by 3. I'm taking the mod. So N is given by 2 by 3. That's it. So these are the direction ratios of the perpendicular. So this is L and this is M and this is N. You have to add all of them to get your required answer. L plus M plus N is equal to 2 by 3 plus 1 by 3 plus 2 by 3, which is nothing but 5 by 3. So you have 5 by 3. That is option B as the answer. Hope you got that. Next is question number 63. The Cartesian equation of a plane parallel to the plane this and at a distance of 2 units from it is. First of all, let's assume the R vector to be equal to xi, yj, zk. Here R given this, that is R vector into 2I plus 3j minus 4k is equal to 1, or xi, yj, z k into 2I plus 3j minus 4k is equal to 1. This will give you 2x plus 3y minus 4z is equal to 1. Now equation, it's given the Cartesian equation of the plane parallel to this plane. A general equation of a plane, equation of plane parallel to, if I say this one, parallel to 1 is given by 2x plus 3y minus 4z is equal to k. Now it's given and at a distance of 2 units from it is. So if I say the distance between the two, d1 minus d2 modulus divided by a square plus b square plus c square, which are the coefficient of x, y, z respectively, that is equal to 2. So that's d1 minus d2, sorry, k minus 1 upon, that's 2 square 4, 3 square 9, minus 4 square 16. That's equal to 2 mod of k minus 1 is equal to 2 into that's 13 plus 16, that is equal to root of 29, or k minus 1 is equal to plus minus 2 root 29, which gives you k either is equal to 1 plus minus this. I'll leave it as such. So the equation of the required plane becomes required equation is 2x plus 3y minus 4z is equal to 1 plus minus 2 root 29, which is option B. So here we have option B as the correct answer. Hope you got that sum. So next is question number 64. If fx is equal to sine of greatest integer function x upon greatest integer function x when x is not equal to 0, and this is equal to 0 when the greatest integer function x is equal to 0. Now, this denotes greater integer function less than or equal to x. Then you have to find out this limit. Limit x approaching 0 minus fx. This is given by limit x approaching 0 minus fx is equal to limit x approaching 0 minus sine of, see, this is equal to minus 1 upon minus 1. And you know this. Question number 64. If fx is equal to sine greatest integer function x upon greatest integer function x, when x is not equal to 0, and this is equal to 0 when greatest integer function of x is equal to 0, then x denotes greatest integer less than or equal to x, then you have to find out this limit. Let's write down. You have to find out limit x approaching 0 minus fx, which is given by limit x approaching 0 minus. So, see, this is fx when x is approaching greater. This is sine x upon the greatest integer function x. So, when x is approaching 0 minus, what will be 0 minus? Where then what will be the greatest integer function of it? It will be minus 1, because we will take the lesser one, right? I hope you know this thing, that the greatest integer function of minus 0.239 is the one that is minus 1. So I'll take the immediately left hand side integer of it. This makes this limit as limit x approaching 0 minus sine of minus 1 upon minus 1. Okay, so that's sine of minus 1 upon minus 1. I have put this. So this is sine of minus 1 upon minus 1. Sine of minus 1 is minus sine 1 upon 1. And this is equal to sine 1. So that means this limit exists and this is equal to sine 1. Option B. Hope you got that. Next is question number 65. Limit x approaching minus infinity. This whole expression is equal to. Okay, so let's write down this expression. Limit x approaching minus infinity, 3 mod x cube minus x square plus 2 mod x minus 5 whole divided by minus 5 mod x cube plus 3 x square minus 2 mod x plus 7. So that's equal to, see, when x is approaching minus infinity, this will be given by minus 3 x cube minus x square. See, because at x approaching minus infinity, the mod is equal to minus x. So this is minus 3x cube minus x square minus 2x plus minus 5 whole divided by 5x cube, 3x square, 2x plus 7. Correct? So when x is approaching infinity, I'll take x common from the numerator and the denominator. So you will have x cube from here. No, I'll do this thing. I'll just put x is equal to minus infinity. So this will be equal to. Question number 65, limit x approaching minus infinity. This expression is equal to what? So let's write down the expression first. This is limit x approaching minus infinity, 3 x cube x square 2 mod of x minus 5 whole divided by minus 5x cube plus 3x square minus 2x plus 7. So when x is approaching minus infinity, the mod of x is equal to minus x. This gives you limit x approaching infinity. This whole expression will be minus infinity minus 3x cube minus x square minus 2x plus 5 whole divided by 5x cube 3x square plus 2x plus 7. Let's take x cube common from the numerator and the denominator. So you have this as minus 3 minus 1 upon x minus 1 upon x minus 2 upon x square plus 5 upon x cube whole divided by x cube, and here is 5, 3 upon x, 2 upon x square plus 7 upon x cube. Now when I put x is equal to minus infinity, first of all these two will cancel and you will have here minus 3 minus 0 plus minus 2 plus 0 0 and 5 plus 0 plus 0 plus 0, which gives me the answer as minus 3 by 5. So here it is, minus 3 by 5 is option D. Hope you understood this. Next is question number 66. It says let fx is equal to this function when x is less than 0. It's equal to p minus q when x is equal to 0, and this function when x is greater than 0. If fx is continuous at x is equal to 0, then you have to find out q upon p value. Now in the question you are given that, this is really important, fx is continuous at x is equal to 0. If the function is continuous at x is equal to 0, that means limit x approaching 0 minus fx is equal to f of 0 is equal to limit x approaching 0 plus fx. Which means if I take this one, I'll write it now. Limit x approaching 0 minus tangent of 2p minus 7x plus tangent 3x whole divided by x is equal to p minus q is equal to limit x approaching 0 plus q into root of x square plus x minus root of x whole divided by x root x. Okay, now I'll see this is of the form 0 upon 0. So I'll do one thing, limit x approaching 0 minus tangent of, divide the numerator and denominator by x, you will have 2p minus 7x upon x plus tangent of 3x upon x upon 1 is equal to p minus q. That's equal to limit x approaching 0 plus q. I will take root of x common from here, and inside you will be left with root of x plus 1 minus 1 whole divided by x root x. These two will cancel, and here you have limit x approaching 0 minus tangent 2p minus 7x upon x. I'll multiply this numerator and the denominator with 2p minus 7. Okay. Plus now here I'll multiply the numerator and the denominator with 3. 3 into tangent 3x upon 3x. That is equal to p minus q, which further is equal to q. See over here, okay, I'm left with limit x approaching 0 plus q into root of x plus 1 minus 1 upon x. So this is of the form 0 upon 0. So I will apply L'Hospital's rule further over here. First of all, look at this one. Tangent 2p minus 7x upon 2p minus 7x, limit x approaching 0. This gives you 1. 2p minus 7, and this is plus 3, because this is 2p minus 7 into 1 plus 3 into 1. This is equal to p minus q. This is number 1. And also the second thing, p minus q is equal to limit x approaching 0 plus 1 upon, I'm applying L Hospital's rule over here, 2x plus 1 upon 1 by using L Hospital rule. So this gives me 2p minus 4 is equal to p minus q, which gives you p plus q is equal to 4. And over here you have p minus q is equal to, this is gonna give you, over here this was being multiplied by q, so that is equal to q into 1 by 2. So that means p is equal to 3q by 2. Okay, so I'll put this p's value over here, 3q by 2 plus q is equal to 4, which gives me 5q is equal to 8, or q value as, I have to find out, q's value came out to be 8 upon 5, right? I have to find out p upon q. To find was q upon p, sorry. To find was q upon p, that is equal to 8 upon 5 divided by, okay, sorry, I'll just read from here only, na. That's equal to 2 by 3 q upon p. I don't need to do all those things. No need for it. So q upon p is equal to 2 by 3. That's it. 2 by 3 is option A. Hope you understood this. Next is question number 67. Question number 67, if x into e raised to power x multiply y is equal to y plus sine square x, then dy by dx at x is equal to 0 is. The given function x into e raised to power xy is equal to y plus sine square x. Let's find out the differentiating both sides with respect to x. You will have y, sorry, with respect to y, you have, sorry, differentiating both sides with respect to x, you have first function into derivative of second, which is e raised to power xy into derivative of dy by dx. Sorry, I'll do this again, this whole sum again. I'll start again. So x into e raised to power xy is equal to y plus sine square x. Now differentiating both sides with respect to x, you have this first function into derivative of second. So e raised to power xy into derivative of xy upon dx plus e raised to power xy into 1 is equal to dy by dx plus 2 sine x cos x. So that's x into e raised to power x, y. I'm taking common from it. So you will have this as x into, now let's find out this derivative. So x into dy by dx plus y into 1 plus exy is equal to dy by dx plus 2 sin x cos x. Okay, I'm taking x into e raised to power xy common. This is x into dy. Okay, see, now you have to find out this integral. I have solved it over here. Now you have to find out this integral at x is equal to 0. Simply let's fill in at x is equal to 0. What will this be? This will be 0 plus e raised to power 0 is equal to dy by dx plus 2 into sine 0 cos 0. That is 1 is equal to dy by dx plus 0. This gives you dy by dx is equal to 1, which makes option D as the correct answer. Hope you understood this. Next is question number 68. Fx is equal to x square sine 1 upon x. When x is not equal to 0 and f of 0 is equal to 0, you have to find out limit x approaching 0, the first derivative of fx. You are given the function fx is equal to x square sine 1 upon x. Let's find out the derivative. So this is first function derivative of second, x square into cos 1 by x into derivative of 1 by x is minus 1 by x square plus first function derivative of second plus the second function into derivative of first. Now limit x approaching 0 f dash x is equal to limit x approaching 0 minus, see this x square and x square will cancel and you have minus cos 1 upon x plus 2x sine 1 upon x. This is something between minus 1 and 1. So limit x approaching 0 f dash x is equal to minus 1 to 1 plus 0. That means limit does not exist. So we have option A as the answer. Hope you got that. Next is question number 69. The derivative of log x raised to power sin x with respect to cos x at pi by 2 is. You are given the equation y is equal to log x raised to power sin x. Let's take log on both sides. Log y is equal to log of x raised to power sin x. Okay. That gives you log y is equal to sin x into log of x. Okay. Now, let's differentiate both sides with respect to x. I have 1 by y into dy by dx is equal to first function into derivative of second. So, sin x into 1 upon log x into derivative of log x is equal to 1 by x plus log of x multiplied by derivative of sin x, which is equal to cos x. So, this gives you, I'll leave it as such, and we have to find out it with respect to cos x, but at pi by 2. When I put this at pi by 2, at x is equal to pi by 2, this becomes 1 upon log pi by 2 into this is equal to 2 upon pi, 1 upon log pi by 2, that is equal to log 2 pi only. Question number 65. The derivative of log x raised to power sin x with respect to cos x at x is equal to pi by 2 is. You're given the function y is equal to log x raised to power sin x. Taking log on both sides, you have log y is equal to log of log x raised to power sin x, or this can be written as log y is equal to sin x into log of log x. Okay. Now differentiating both sides with respect to x, you have 1 by y into dy by dx is equal to first function to derivative of second. So this is equal to 1 upon log x into derivative of log x is equal to 1 by x plus log of log x into derivative of sin x is equal to cos x. So this is the value of the given function when I have calculated the derivative with respect to x. Now, at x is equal to pi by 2, this equation becomes dy by dx into 1 upon y. And what was 1 upon y? It was log pi by 2 raised to power sine pi by 2 is equal to sine pi by 2 into log 1 upon log pi by 2 multiply by 2 upon pi, because 1 upon x will be 2 upon pi plus this is cos pi by 2. So this whole expression will come out to be 0. Further, dy by dx multiply 1 upon log pi by 2 raised to power sin pi by 2 is equal to 1. So this is log pi by 2 as such. This is 1 into 2 pi multiply 1 upon log pi by 2. This 2 will cancel and you will have dy by dx is equal to 2 upon pi. Correct? Now, let's suppose you have to find out actually the derivative with respect to cos x. So let this x, cos x is equal to some t. So dt will be equal to minus sin x. dt upon dx will be equal to minus sin x. Correct? At x is equal to pi by 2, dt upon dx is equal to minus sine pi by 2, which is equal to minus 1. We have to find out dy by dt actually, because we have to find out the derivative with respect to cos x for the given function. Now this is equal to dy by dx upon dt by dx. What was dy by dx? That was equal to 2 pi, 2 upon pi upon minus 1. So dy upon dx is equal to minus 2 upon pi. That's it. This is answer to the question. Minus 2 upon pi is option C. Hope you understood this. Let's move to the next question, number 70 then. Let fx be differentiable function for all x belonging to real numbers and fx plus y is equal to fx plus fy minus 3xy. If limit h approaching 0, f upon h is equal to 7, then you have to find out the first derivative of the function. Okay, you are here. See, you have to find out f of dash x, right? When h is approaching 0, this is f of x plus h minus f of x upon h, correct? So this is limit h approaching 0, fx. See, x plus y, fx plus y is equal to fx plus xy minus 3xy. So this is equal to fx plus fh minus 3 into x into h minus f of x whole divided by h. These two will cancel and you will have limit h approaching 0, fh minus 3x into h. That's limit h approaching 0, fh upon h minus limit h approaching 0, 3xh upon h. Now this is, you are given that this fh upon h is equal to 7. So that's equal to 7 minus 3x into 1. So that's it. F dash x is equal to 7 minus 3x, which is option A. So option A is the correct answer. Hope you got that. Next is question number 71. Equation of the tangent to this curve at x is equal to 0 is okay. So, tangent touches the curve at this point. So that means at the point where the tangent is touching the curve. Okay, I'll write down the curve equation. X into y raised to power 5 plus 2x square y minus x cube plus y plus 1 is equal to 0. Now add x is equal to 0 because tangent is touching the curve at x is equal to 0. What is the value of y? 0 plus 0 minus 0 plus y plus 1 is equal to 0, which is y is equal to minus 1. So the point of contact is 0 comma minus 1. Okay, now this equation, let's x into y raised to power 5 plus 2x square y minus x cube plus y plus 1 is equal to 0. Differentiating both sides with respect to x, you have 5x y raised to power 4 multiplied by dy by dx plus y raised to power 5 plus 2x square y dash plus 4xy minus 3x square plus y dash is equal to 0. So now at x is equal to 0, you have this as 0, and at this point y was minus 1 raised to power 5 plus 0 plus 0 minus 0 plus y dash is equal to 1, which gives you y dash is equal to 1. Okay, so that means here at this point, slope, this represents, the first derivative represents slope. So at this point, slope is equal to minus 1. You have to frame the equation of the tangent. Equation of tangent at 0 comma minus 1 and slope 1 minus 1. Sorry, slope is 1, not minus 1. This is given by y plus 1 is equal to 1 into x minus 0, or y plus 1 is equal to x y is equal to x minus 1. This is the equation of the tangent. Option B. Hope you understood. Next is question number 72. A particle moves in a straight line such that displacement s in meters at a time t in seconds is given by this. The instantaneous velocity v at time t is equal to 4 is. So you are given the particle moving in a straight line with a displacement. S represents displacement, t represents time. So displacement is given by this function. S t is equal to t raised to power 3 minus 4t square plus 7t. Now, displacement with respect to time gives you velocity. So let's find out the derivative of it. This is 3t square minus 8t plus 7. Now you have to find this. This actually represents velocity. Instantaneous velocity at t is equal to 4 is d st upon dt is equal to 3 into 4 square minus 8 into 4 plus 7. That's 16 3s are 48 minus 32 plus 7, that is equal to 23. So this is the answer to the question, 23 meters per second. Option B. Hope you understood this. Next is question number 73. If the two curves x is equal to y square and this cut each other at right angles, then what is the possible value of k? You are given the two curves as x is equal to y square and xy is equal to k. So here dx is equal to 2y into dy, and here you have I can say y is equal to k upon x, correct? Here the first m1, the slope m1 is given by dy by dx, so that is equal to 2y, 1 upon 2y. And in the second case, m2, that is dy by dx is equal to minus k upon x square. You know, since they are at right angles, that means the product of their slopes is equal to minus 1. That means 1 upon 2y multiply minus k upon x square is equal to minus 1, or k is equal to 2x square y, which can be written as 2x into xy, which is equal to 2x into k. That simply means 2x is equal to 1. Right? So 2x is equal to 1, which gives you x is equal to 1 by 2. And you know the equation, first one was x is equal to y square. So that means y square was 1 by 2, which gives you y is equal to 1 upon root 2. And the second, k is equal to xy. So that is 1 by 2 into 1 upon root 2. That is 1 upon 2 root 2. So this is the value of k. 1 upon 2 root 2 is option D. Hope you got that. Next is question number 74. The Rolle's theorem is not applicable to fx is equal to x for x lying between 0 and 1 and 2 minus x for x lying between 1 and 2. On 0 to 2 is fx is not defined everywhere, fx is not continuous, f0 is not equal to f2, fx is not differentiable. Okay, so you're given this function, these two functions. Now let's check the continuity of this function. Limit x approaching 1 minus. If the function is continuous, then this should be equal to f of 1, which further should be equal to limit x approaching 1 plus 2 minus x fx. Okay. Okay, this is supposed to be continuous at 1. So this should be equal to 1, and even this should be equal to 1. Now, see over here, f of 1 is equal to 1. So that means even this function should be equal to 1, and this one also should evaluate to be equal to 1. Okay, next. Question number 74. The Rolle's theorem is not applicable to fx is equal to x when x lies between 0 and 1 and 2 minus x when x lies between 0 and 2 on 0 to 2. Let's check the continuity of the function. For the function to be continuous, limit x approaching 1 minus. This is fx is equal to, see, this is 1 for 1 minus, this will be equal to x, and that is equal to 1. Okay. All right. And limit x approaching 1 plus fx will be equal to 2 minus x, that is 2 minus 1, which is again equal to 1. So also f of 1 is equal to 1 only. F of 1 is equal to 1. So therefore the function is continuous. Let's check the differentiability of the function. So this is the given function, fx is equal to x. Let's differentiate with respect to x. You have the 1 over here. For fx is equal to 2 minus x. Let's find out the differentiating it. You have the minus 1 as the answer. Since they are not equal, therefore the function is not differentiable, which makes option D as the correct answer. Hope you understood this. Next is question number 75. Okay, integral problem before us. You have integral of this whole expression. You have to find out the integral of this whole expression. Let's start. So this can be written as integral of x into e raised to power x square upon x square minus 2 whole divided by, this can be written as x minus 2 whole square dx. Let's put some t is equal to x square upon x square minus 2. So dt upon dx will be equal to x square minus 2 whole square into x square minus 2 into 2x minus x square into 2x. That will be equal to minus 4x upon x square minus 2 whole square. So x upon x square minus 2 whole square dx is equal to dt upon minus 4. That means, now let's get back to our integral. Let's fill in all of these in equation 1. So from equation 1, integral of e raised to power t into dt upon minus 4 is equal to minus 1 by 4 e raised to power t plus the constant c. So this is equal to minus 1 by 4 into e raised to power x square upon x square minus 2 plus the constant c. This is option A. So option A is the correct answer. Hope you got that. Next is question number 76. You have to integrate. You are given this integral is equal to fx plus c, then f of 1 minus f of 0 is equal to. Basically, you have to find out what is fx. If you get this, then you will easily get this answer. Okay. Basically, I have to find out this integral only. So let's write it down. This is, I'll start with the question. It's given from here. This is equal to integral of 2x raised to power 12 plus 5x raised to power 9 whole divided by, I'll take x raised to power 15 common from here. 1 plus 1 upon x square, 1 upon x raised to power 5 cube dx. This can be written as integral of 2 upon x raised to power 3 plus 5 upon x raised to power 6 whole divided by 1 plus 1 upon x square 1 upon x raised to power 5 whole raised to power 3 dx. So now let's put 1 plus 1 upon x square x raised to power 5 is equal to some t. So let's find out the derivative. This will be minus 2 upon x cube plus minus 5 upon x raised to power 6 dx is equal to dt. So the integral now becomes, this integral now becomes integral of minus dt upon t cube. Now you are having this as integral of t raised to power minus 3 upon dt, which is equal to minus t raised to power minus 2 upon minus 2 plus the constant c. That's equal to 1 upon 2 t raised to power 2 plus this. Let's fill in the value of t. This is equal to 1 by 2 into x raised to power 5 upon x raised to power 5 plus x cube plus 1 plus c. So let's compare it with the given one. This one. This gives you fx is equal to, this is the value for fx. You had to find out f of 0. So f of 0 is equal to simply, that's going to give you 0. That's C. Okay, and f of 1 is equal to 1 by 2 into 1 upon 1 plus 1 plus 1 plus the C. That is equal to 1 upon 6 plus C. You have to find out f of 1. Wait. I forgot this square over here. This has to be there. So this is equal to 9 into 2, 18. You had to find out f1 minus f0, which is 1 by 18 plus c minus 0 minus c, or that is equal to 1 by 18. So you have option B as the correct answer. Hope you understood this question. Next is question number 77. Integral of root of cos x upon sine 2x. Let's go. So integral of root of cot x sine 2x can be written as 2 sine x cos x. So that's equal to root of, integral of root of cot x upon cot x into, can I write it like this? 2 sine square x dx, right? Or that is equal to, this is cot raised to power minus 1 by 2 x, right? Into cosecant square x dx. I'll take 1 by 2 outside. I hope you're clear till here. What I did, I divided the numerator and the denominator by cot x. So over here, root of, cot x upon cot x, and you will get here cot x, root of cot x upon cot x into 1 upon 2 sine square x. And I did cut this. So this is equal to root of cot x, which on getting into the numerator, this will be cot raised to power minus 1 by 2x. And 1 by 2 is taken outside. Sine square x is equal to 1 upon sine square x is equal to cosecant square x. Okay. Now let's put cot x is equal to some t, which gives you minus cosecant square x into dx is equal to dt, or this will be equal to 1 by 2 t raised to power minus 1 by 2 into minus dt. That is equal to minus 1 by 2 t raised to power integral of minus 1 by 2 dt, which will be raising the power by 1. So this will be t raised to power minus 1 by 2 plus 1, which will be 1 by 2 divided by the added power plus the constant c. So that is equal to minus, okay, this will cancel out. And you will have minus t raised to power 1 by 2 or this is minus root t plus c, that is equal to minus root of cot x plus c. So here we have minus root of cot x plus c is option B. Hope you understood this question. Let's move to the next question, number 78 then. Limit n approaching infinity 1 by n. This whole expression is equal to integral 1 to 2 fx dx. Then you have to find out f of x. Okay. So first thing you are given the question, the LHS. I'll pick up the LHS first. That is limit n approaching infinity 1 by n log of 2n factorial upon n raised to power n into n factorial. That is equal to 2n. I'm opening the 2n factorial, 2n into 2n minus 1 into 2n minus 2, so on, n plus 1 into n factorial. This whole will be divided by n raised to power n is n into n till n times, multiplied by n factorial. So these two n factorials will get cancelled over here. And further, this is equal to 2. So this n and n will cancel. 2 multiply 2 minus 1 upon n, 2 minus 2 upon n, 2 minus 3 upon n, 1 plus 1 upon n, which further is, you can write it as 1 plus 1 upon n, 1 plus 2 upon n, 1 plus 3 upon n, so on, 1 plus n upon n. This I have written in the reverse order. This I have written the first, then the second term over here, the third term over here is written over here. Similarly, 1 plus n upon n, this means 2. Now let's get back to, we were having one limit n approaching infinity, 1 by n log of this. So limit n approaching infinity log of this 1 by n, this whole thing, 1 plus 1 by n, 1 plus 2 by n, 1 plus 3 by n, so on till log of 1 plus n by n. That can be written as 1 by n. Give me a minute. 1 by n was outside, not over here. So that's equal to log 1 plus 1 by n plus log 1 plus 2 by n, log 1 plus 3 by n, so on till log 1 plus n by n. Correct? So that's equal to limit n approaching infinity. That becomes 1 by n into summation from r is equal to 1 till n log of 1 plus r upon n. So here the lower limit n approaching infinity, this is equal to 1, and the upper limit is limit n approaching infinity 1 plus n upon n, which is equal to 2. And that is equal to integral of limit 1 to 2 log of x dx. Therefore, fx is equal to nothing but log x, right? So we have option C as the answer. Hope you understood this. See, in the last step, we had this and the question, then fx is equal to, you had to find out fx is equal to from limit 1 to 2. This was the limit n approaching, the upper limit was limit n approaching infinity 1 upon n plus n, that's equal to 2, which means from 1 to 2 limit, that's equal to log of x dx, which means f of x is equal to log x. Next is question number 79. Limit minus pi by 2 to pi by 2 sine x minus greatest integer function x dx is equal to. See, this limits can be broken down. This can be written as minus pi by 2 to minus 1. This will be sine x plus 2 dx. Then minus 1 to 0, this will be sine x plus 1 dx. Then 0 to 1 sine x dx plus limit 1 to pi by 2. This is sine x minus 1 dx. Now let's find the integral. Now it's pretty easy to solve. Sine integral is cos. This will be given by cos x plus 2 limit minus pi by 2 to minus 1 plus cos x plus 1 minus 1 to 0 cos x 0 to 1 cos x minus 1 1 to pi by 2. So this is equal to cos minus 1. Okay. So this is equal to 1 cos minus 1 plus 2. This is equal to this minus question number 78, limit n approaching 0, 1 by n log of this whole expression is equal to limit 1 to 2 fx dx. You have to find out what the fx is equal to. I'll just start with this expression, which is given in the brackets, and then solve, and then I'll take the whole LHS. Okay. First, 2n factorial upon n raised to power n into n factorial is given by 2n into 2n minus 1, 2n minus 2 till n plus 1 into, I'll leave n factorial over here, and n raised to power n can be written as n into n into n times multiplied by n factorial. So these two will cancel. And now I will use the LHS, which is limit n approaching infinity. Okay, not right now. I'll solve it a bit more. So this can further be written as 2 into 2 minus 1 upon n into 2 minus 2 upon n into 2 minus 3 upon n, so on 1 plus 1 upon n. I'll start from writing from here now. So this can be written as 1 plus 1 upon n into 1 plus 2 upon n, 1 plus 3 upon n, so on 1 plus n upon n. See, this is equal to 2 actually. Okay, so now limit n approaching infinity, 1 by n log of 2n factorial divided by n raised to power n into n factorial is equal to 1 by limit n approaching infinity, 1 by n log of this whole thing, right? So see, they are in the multiplication form, so I can write them like this: log of 1 plus 1 upon n plus log of 1 plus 2 upon n plus log of 1 plus 3 upon n, so on log of 1 plus n upon n. This is something equal to 1 by n summation from r is equal to 1 to r is equal to n log of 1 plus r upon n. So for here, the lower limit, what is that? It's this. Lower limit is equal to limit n approaching infinity 1 upon this. So that is equal to 1. And upper limit is limit n approaching infinity, this, and this is equal to 2. So this limit becomes, that means this is equal to lower limit 1, upper limit 2, log of x dx. That means in the question, see, this is equal to limit this. So that means fx is equal to log of x. Fx is equal to log of x. That means we have option C as the answer. Hope you understood this. Let's move to the next question, number 79. Integral of minus pi by 2 to pi by 2 sine x minus greatest integer function of x dx is equal to. See, this can be broken down into minus pi by 2 to minus 1 sine x plus 2 dx plus minus 1 to limit to 0 sine x plus 1 dx plus 0 to 1 sine x dx and 1 to pi by 2 sine x minus 1 dx. So let's find out the integral now. This is equal to cos x plus 2 limit this plus cos x plus 1 limit minus 1 to 0. I forgot this minus sign over here. Plus minus 1 into cos x 1 to 0 plus minus 1 into cos x minus 1 pi by 2 to 0. So this is equal to minus 1 into cos minus 1 this. So this is equal to cos 1 minus cos 2 plus pi by 2 minus 1 cos 1 and this is minus cos 0 plus minus 1 into, so minus, I'll just write it like this. So this is cos 1 minus cos 0 minus 1 cos pi by 2 minus 1 minus cos minus cos of, this is minus 1. Okay. So that's it, I think. This is equal to cos pi by 2 plus 2 minus cos 1 minus cos 1 plus cos 0 minus cos 1 plus cos 0 minus cos pi by 2 minus 1, and that's equal to cos of minus cos of 1 only, because cos of minus 1 is equal to minus 1 only. Okay, so this is equal to 3 cos 0 minus 3 cos 1. Cos pi by 2 plus 2 is equal to cos pi by 2. See, this will be changed into sine. So this is equal to plus sine pi by 2 and minus cos pi by 2 minus 1. This is equal to minus sine 1. So that's equal to 3. Cos 0 is equal to 1. So 3 into 1 minus cos 1 plus, sorry, here was 2. So sine 2 minus sine 1. See, this has been changed and this has been changed over here. So this is answer to the question. I'll rewrite it in the proper form once again. 3 into 1 minus cos 1 plus sine 2 minus sine 1. This is option A. So this is the correct answer to the question. Let's move to the last question of the paper with this question number 80. The solution of dy by dx is equal to root of 1 minus y square. Y of 0 is equal to 1 is. Okay, the solution, first of all, you are given that dy by dx is equal to this, and y of 0 is equal to 1. Integral of dy upon this is equal to dx integral. This is the integral of 1 minus sine 1 minus y square root, sorry, integral of this is equal to sine inverse y. So this is equal to sine inverse y is equal to x plus c, or y at 0 is equal to 1. This is given to you. This means sine inverse of Yeah, sine inverse of 1 is equal to 0 plus c, which means c is equal to sine inverse of 1, or sine inverse y is equal to x plus sine inverse of 1. This is the equation. Option B stands to be the correct answer. Hope this is clear to you. And students, with this, we have completed all the 80 questions of this paper. I hope you have well understood them. So students, here's a quick reminder to visit our website, www.examsnet.com. Do explore our website for more exposure to such type of question papers. Their PDF solutions are also available there. For your convenience, we have our app. The link is available in the description box for the app. You can download it and explore it. So students, that's all for this paper. Keep exploring, keep rising high, keep shining. Best of luck for your exams. That's all for this paper. Bye and best of luck.